data and learn to use the Xcode integrated development environment to speed up your workflow.
For your final project, you will create a well-designed, high-performance iOS mobile application for your portfolio, complete with interactivity, to showcase during your job search.
You'll also be ready to collaborate with other developers, as you will have learned to use Git and GitHub for version control.
If you're hoping to operate independently or in a smaller team, not to worry. We've also got you covered when it comes to the basics of user experience.
You'll learn how to research a user's needs, create wireframes using popular industry tools like Figma, and design interactivity.
In the final course, you will prepare for the coding interview. You'll practice your interview skills, refine your resume, and tackle some common coding challenges that typically form part of technical job interviews.
Once you complete the program, you'll get access to the Meta Career Program's job board,
a job search platform that connects you with over 200 employers who have committed to sourcing talent through Meta certificate programs.
Who knows where you'll end up? Whatever the future of connection looks like, you'll be part of its creation. Let's get started.
Swift is a versatile, high-level programming language available on Apple's platforms. It's a language that's used by companies large and small to build a diverse range of applications. Platforms that use Swift include iOS, tvOS, and macOS. The Swift programming language syntax is very similar to English. It's intuitive, and beginners will often quickly understand what's going on. It's also a great choice for experienced programmers who will appreciate its power and adaptability. Because Swift is a very popular software development tool, it's important for you as a new developer to know how it works and to know how to code with it. This course covers the key points you need to know to begin programming in Swift. To begin, you'll learn about the Swift programming language and its associated foundational concepts. You'll learn to recognize common applications of Swift, and you'll be able to explain foundational development concepts and use variables, conditionals, and loops to solve a coding problem. Next, you will build on what you've learned by discovering the fundamental data structures that allow you to store data, including arrays, tuples, and dictionaries. Thereafter, you'll learn about functions and closures and discover how they are used for code reusability. And then you'll discover how to create general-purpose programming blocks for your code by learning about structures and classes. Finally, to demonstrate your Swift coding ability, you'll complete an exercise using the skills and knowledge acquired from this course. You may have encountered some concepts or terminology in this video that you don't fully understand yet. Don't worry about that right now. This course will take you through these concepts step by step and give you a solid coding foundation in Swift. Good luck on your coding journey.
And now's a great time to learn Swift because the iPhone is the biggest device out there. And you can definitely build a career out of it and become very successful and potentially build the next app that everyone's using. Hi, my name is Chris. I've been at Meta for 7 years. In the last 4 years, I've been working on Instagram. I first found out about Swift when the language was introduced about 8 years ago. I found it to be this language which will make building an app even faster, even more beautiful. And I love the simplicity. If you're kind of writing code in a lower level language, a lot of time you have to think about memory and kind of these lower level concepts. And you're not really spending a lot of time just creating something beautiful or making something kind of like feel the way you want it to feel as you like scroll through the app. And I think Swift really kind of tries to make it so you can spend a lot more time thinking about that, really polishing the experience, building something that you kind of really enjoy using, as opposed to kind of trying to deal with some technical details that maybe are not really that relevant. Swift, I think, is still kind of like ramping up. So it's still, I think, in the industry seen as kind of really only solving the iOS problem and kind of only really working on iPhones. I think in the future, Apple really wants to make it a language that's very versatile, that can do anything, maybe something like a JavaScript. But I think we're still far from that world. The question to ask of like, should I kind of spend my career in Swift? It's really a question of how long is the iPhone going to be around? If you believe the iPhone is going to be around for 10, 20, 30 years, then Swift is going to be around for at least 10, 20, or 30 years. I would say pretty much every app that is on your phone right now probably has some Swift. I think right now, if you really see the iPhone as like a way to build something incredible and distribute something incredible, it's definitely the language of choice. Do you really want to build something and be able to see it right away? It's always, I think, the most motivating to build something, right? To create something from scratch, to kind of see something on screen, be able to like press it, touch it, like kind of have that interaction with it. I think a lot of times when people start programming, they'll create a website, they'll see something and it's really, really cool. But all of us use our phones all the time, every day. And I think that feeling of putting something on your phone and creating a button or something where you could kind of, go through your pictures or do something cool with it, it's just such a powerful feeling when you realize like, wow, I can create anything. Big companies tend to want to hire maybe a little more experienced engineers when it comes to mobile development. I think the reason for that is it could be hard for a lot of mobile engineers to really get into a large legacy code base, maybe because a lot of big companies have a lot of Objective-C or lower level languages. Most companies that I kind of read about these days, especially in terms of startups, everyone's kind of mobile first. And if they're mobile first, they're going to have at least a couple of iOS engineers, a couple of Android engineers. And so there's just tons of opportunities out there right now to really break into the career as a mobile engineer and kind of really build out some amazing apps. What I run into a lot is Swift engineers who get really excited about building products. There's a type of engineer who's this hybrid of a product builder, a product designer, and they really, really care about the experience themselves. And engineers like that, they want to spend their time in the product space, like building something, designing it, making it beautiful. They don't want to kind of spend a lot of time maybe in like the infrastructure aspects of it. And so a lot of those engineers really like simple languages that help you abstract and spend your time kind of getting that aspect right rather than kind of focusing on different sets of problems. So those engineers get really, really excited about Swift. I think in every industry, whether it's movie making or programming, there's the people that like want to create something, want to leave their mark. And I think find that passion and that drive in what you want to create and kind of go again after it. And I think if your angle is, okay, I'm going to be most motivated to create something because I use my iPhone. If I put an app on the App Store and get my friends to use it, that's going to be the way to get them kind of interested in what I'm creating. Then Swift is the choice for you. So all of our interviews for iOS engineers are done in Swift. It's growing. Its adoption is kind of picking up as well. It's made its way to the big four apps that we kind of support, namely Facebook, Instagram, Messenger, and WhatsApp. And I think the main apps, which have a legacy code base that exists since before the language even existed, they're kind of adopting more and more Swift. So my name is Chris. I work at Meta in the New York office, and I've been working on Instagram for the last 4 years, half of those as an engineer and half as an engineering manager. The first year or so of Swift, it was a very new language, and it was an unstable language, right? All the big companies were scared to touch it. It was kind of something where you knew things can break. You knew they would make updates to the language where it would kind of like break everything you've written in it. And that's just not something we can do at a big company. And then Swift at some point reached what they call API stability, which is when you kind of have this guarantee that even as the language evolves, old usages of the language won't break. And as soon as that happened, we kind of kicked off this project where we had some very amazing engineers kind of get together and look at the code base and kind of assess the language and see the risks. And we kind of took all that context together and made a decision of like, are we ready or not for Instagram and the code base? We decided, okay, let's give Swift a shot in Instagram. Let's kind of make that work. And then we spent kind of several months making it possible so that we got to a state where product engineers can really build product features in Swift. And I'm happy to say that a lot of the most recent product development, a good chunk of it has been in Swift. If you think of code as a tree, right? The most core areas of that tree, like the trunk, is going to be a lot of the infrastructure, right? Like what all the other code is kind of depending on. And then as you go further down the tree, you're going to get closer and closer to the UI where like the product really lives. The core aspects of that tree are going to be in kind of like lower level languages because they're stable, people aren't touching them too much. The way we kind of see the migration is we really want to enable kind of like the leaves of those nodes to kind of be able to work in Swift. And so the question is like, how much UI can be built in Swift? And once the UI is there, can we start building some of the data flow in Swift? The big difference there between Swift and Objective-C is just how powerful the compiler is. There's certain rules you could enforce in Swift that you can't in Objective-C. One concept is this concept of nullability, right? If you have some object in memory, right now in older languages, you have no guarantee whether that object actually contains something or really is nothing. And in modern languages like Swift and Kotlin, you can have the compiler say like, this is guaranteed to be something or it's guaranteed to be maybe something, right? And I think a lot of older languages just didn't have that concept. And so when you have those guarantees, you can kind of write code in a way that's it's just safe to make certain assumptions, and then you could express things in just like a much cleaner way with much less code. There is this new framework in Swift called Swift UI, very, very nicely named, which is kind of like how Apple envisions the new way to build interfaces in the future. The whole kind of framework and the APIs in the framework are designed in such a way where anyone can really come with very little experience and build really beautifully functioning apps. I think what Instagram and specifically my team really, really cares about is, can we get to a world where we can get product engineers to be able to design things using that framework? That framework is still in early phases of development. So if Swift is 8 years old, Swift UI is only 4 years old. And yeah, with every single iteration, it becomes more stable, easier to use. And with every single year, we also kind of assess it as a company of, is it ready for us to kind of use in production? Can we start building Instagram features in this framework? And I think everyone's really excited about it. It's a beautiful framework. It makes it very easy to express even the most complex layouts. I would love to see the world where these frameworks become so easy to use that you don't even need an engineer. You could just go to a designer and be like, hey, can you build this? And the designer can just do it directly. And I think that's the world that we all want to get to, and kind of like the dream we want to get to. And I think Swift UI is definitely a step closer to that world. It's really not about the company or the project or the technology. It's really about the people, right? You want to kind of surround yourself with the most talented people you can. I really believe in the saying of, you are the 5 people you spend the most time with, and you want to make sure that you're around those type of people. And so I think, how would I connect that back to Swift? Again, I think that the people that have the most exciting and rewarding careers in Swift are, I think, those engineering archetypes that really love building products, really love designing things, are working with designers, really like working with product. If that's your driving force, if you're kind of a creator, a builder of things, then I think you'll find yourself surrounded by those type of people. And I think your career will thrive and grow. And I think learning Swift will position you to be kind of around those builders, right? I think a lot of people that are passionate mobile experts love building these things and love iterating on that product.
Xcode contains all the tools developers need to build amazing applications for iPhone, iPad, Apple TV, and Apple Watch. In this video, you'll learn how to navigate your way around the Playground UI, or user interface. Please note that you can find an Xcode download guide in the additional resources reading following this video. In the meantime, let's explore a real example of Xcode Playground. Once you have downloaded Xcode from the Apple App Store and installed it, open your Applications folder in Finder and double-click the Xcode icon to launch it. Once the welcome screen appears, the next task is to launch a Playground. To do this, go to the File menu, select New from the drop-down menu, and then select Playground. Once the Playground has launched, choose a type. For this exercise, choose Blank and click Next. Give the Playground a name or accept the default. Let's call it first, and then click Create. This is a Playground. In the left-hand panel are various directories. In the central panel are 3 lines of code and a play icon, and the right-hand panel is currently empty. When I press the play button, it launches the simulator and then outputs the code in line 3. When I hover the cursor over the outputted code, icons appear with the tooltip Show Result and Quick Look. When I click Quick Look, it displays what the variable is set to. In this example, it's Hello Playground. If I click Hide Result, then it displays the variable in the central panel code block. Now, if I go to the top left-hand side, you'll notice there's a Hide or Show navigator. If I click it, the directory navigator closes and vice versa. On the right-hand side, you have hide or show inspectors. These allow you to change how the playground is run. Notice that the platform here says Mac OS, but I could also build one for iOS. Now, it is faster to actually run most of them in Mac OS because it runs on the machine itself. I'll hide this for now. Next, I'm going to add an extra statement to the code block in the central panel. When I type print, notice that Xcode will provide suggestions to make the coding process faster. Then, I type the rest of the statement, putting hello everyone inside double quotation marks and wrapped in parenthesis. This time, when I run the code, it not only outputs to the right side of the screen, but also to the lower panel, which is called the console. This video provided you with a very basic overview of the playground's key features that you will need to familiarize yourself with for this course. In this video, you had a quick tour of Xcode and the Playground app. Great work! Computers and their programs are integrated into our lives at a scale we could not have imagined. Over the past 20 years, we have seen dramatic jumps in technological gains in many areas of computing, mobile devices, the cloud, artificial intelligence, and self-driving cars. In the next few minutes, you will explore a brief overview of the history of programming. And you will also learn the basics of how programming works. Computing dates quite far back in our history and has its origin in something called the analytical engine. This was a mapping device that used mechanical gears and was computed by manually moving hand cranks. Okay, so with the historical side of things covered, let's now delve into understanding what programming is. Before you cover programming, it is helpful to understand how computers work at the most fundamental level. Computers only understand something called binary code, which consists of 2 digits, 0 and 1. This may seem quite strange at first, but with a little explanation, it will all make sense. 0 and 1 relate to different electrical states, similar to a light switch. 0 is equal to off, and 1 is equal to on. For example, in programming, when you calculate numbers, cost, or any arithmetic, you mostly use decimal numbers. Every program written needs to be converted to binary code or machine code. An example of decimal to binary conversion is decimal 1 is binary 1, decimal 2 is binary 1, 0, decimal 3 is binary 1, 1, and so on. A computer represents the binary code by using tiny electrical conductors called transistors. These transistors are located inside the central processing unit, or CPU, which is essentially the brain of the computer. When a program is written using any type of language, it needs to be compiled or interpreted. The outcome is to turn readable programming code, for us, into readable programming code for the computer. It is extremely hard for humans to read and understand binary, and therefore using it is error-prone. It is far easier for us to read and write programming languages. So, what is programming? Programming is the ability to provide a computer with a set of instructions in a particular language that it can understand and perform these operations or tasks. In other words, you need to tell the computer what you want it to do in a format and language it can understand. Programming is a skill. The more you practice and learn, the better you become. At first, it can take quite a while to write straightforward programs. As you progress, you'll become more familiar with the language and how the logic and conditions should be applied. Programming is also a creative skill. That's because you can write computer programs to solve problems in many different ways. And that brings us to the end of this video. You now know a brief history of programming and how typical computer programming works. As you progress through your learning journey, you'll become quite familiar with constants, variables, and data types. In short, variables and constants allow you to organize and store values of the same type. Think of variables as storage pots in a kitchen. Each pot is used to store specific ingredients. One day you use a pot to store all your bananas in, and the next day you use it for oranges. So every day the contents inside of the pot may change. Similarly, the values that are stored in a variable may be changed, whereas the value of a constant cannot be changed. Ultimately, both are used to store specific data types. Don't worry if this sounds complicated now. This video will help you build a foundational understanding of what constants and variables are and how they are used. Variables are an essential part of programming, and they are used to store all different types of data. You might even say they are the cornerstone of programming because they allow you to work with and manipulate data. Variables allow you to make the exact same code produce different results, making your programs versatile. Therefore, it's important that you can identify variables and recognize how they are used. In Swift, you use constants and variables to create and store values. A constant is a value that can't be changed, while a variable can store a value that can be changed over the lifetime of the app. Now, let's explore the syntax you use to create or declare constants and variables. To declare a constant, you start by typing the keyword let, followed by the name of the constant you want to create. This name can be almost anything you want. Next, you need to assign a value to be stored in this constant, and to do that, you type the equal symbol. The equal symbol is known as the assignment operator. You will learn more about operators later, but for now, just know that you need to use the equal symbol to assign a value to be stored. Finally, you need to type a value. Swift organizes its data into many different types, and you will learn about them soon. In this case, let's use a simple numerical value such as 10. Recall how you printed a number earlier? Well, you can print constants too. Just type the print function and place the name of the constant inside the parenthesis. Let's now check how to create and print a variable. To do that, you use the exact same process, except you switch the keyword from let to var. Okay, so now you know that a constant is a value that can't be changed, while a variable can store a value that can be changed. Developers use these rules depending on the type of data they need to work with. For example, suppose you are working on a social media app that displays a user's age and you decide to store this value. Well, this value would need to be stored as a variable using the var keyword, since the value of age will change every year. Finally, it's important to know that you can't declare two variables or constants with the same name, or you will get an error. Also, Swift doesn't allow you to declare a constant or a variable that use mathematical symbols or start with a number. As a developer, you will write a lot of code over time. And while you can name your variables and constants almost anything you want, using generic terms like x and y doesn't give any information about the variable or constant, or where and how it is used. Using meaningful names that make sense in the given context will allow you and your fellow developers to easily understand what's going on. Okay, so now that you know how to declare and assign constants and variables, let's learn about data types. When it comes to programming, a data type is an attribute that describes the specific value that a constant or variable will have. So where the pots represent the variable, the type of goods that go in the pot represent the data types. For example, this pot will hold fruits. This pot will hold vegetables. Data types tell your system how to interpret values so that it can collect and use information in the appropriate format. The first data types you will learn about are those used to perform arithmetic operations. They are called integers and floating point and are represented by the keywords int and float. Integers are used to represent whole numbers and have a type named int. You have already used this type when you printed the number 10. Floating point represents numbers with a decimal point like 10.50 and have a type named float. Both integers and floating points have various subtypes, and these are used to represent how large the number can be. For example, there are two ways to store a floating point number. One way is with a float, which represents a 32-bit floating point number. What this means is that there are 32 bits of storage available for a number of type float every time you use one. This will allow you to represent a very large number before you run out of space. For example, 2,147,483,647. That's a lot. But wait, a double is also used to store a floating point number. This type has 64 bits allocated to it. That means it can store a very large number. For example, numbers in the quintillion and quadrillion magnitude can use a double. Along with numerical types, Swift provides other types, such as the Boolean data type, which is used to represent logical data. Essentially, it can have a value of either true or false. There are other types too, such as string, to represent text, but you will learn more about them later. You can also find a full list of data types from the additional reading at the end of this lesson. Okay, before you finish up, let's explore one of the main ways Swift helps you work with constants, variables, and data types to help write error-free code. Swift is known to be a type-safe language, and this essentially means that there are restrictions on mixing different data types and values. For example, constants and variables must be declared before they can be used, and you can't mix data types. This is because Swift will perform type checks before compiling your code. This means that you do not have to specify the data type when declaring constants and variables. Swift will work out the data type based on the value that you assign, and this is known as type inference. In this video, you learned about constants, variables, and data types. You also learned that Swift is a type-safe language and uses type inference to assign data types. In programming, developers use operators to perform operations on variables and values to manipulate individual data items and return a result. For example, you may already be familiar with the assignment operator to assign a value to a variable. In this video, you will learn about mathematical operators, compound assignments, and type conversions. First, let's start with the mathematical operators you can use to perform simple arithmetic. At this stage, you're probably familiar with the types integer and floating point, and that computers can perform two kinds of arithmetic based on these types. By default, these are the two fundamental data types that will be assigned automatically, int and double. Operators are used to perform calculations using these different data types, similar to how you would use math in your everyday life to solve common problems. For example, working out if you have enough change to get a muffin with your to-go coffee. So, to perform basic mathematical operations on data types, you can use the four operators: add, subtract, multiply, and divide. For example, suppose you create a variable named firstValue and assign it the value of 3 multiplied by 10, which is 30. Now the value of 30 will be stored in the firstValue variable. You can also perform calculations based on other variables. For example, suppose you create another variable named secondValue and assign it a value of 10. Now if you assign the variable firstValue to be secondValue multiplied by 12, firstValue will have a new value of 120. You can also modify a value based on itself. Suppose you create a variable named firstValue and assign it a value of 10. Next, you want to perform a calculation based on the value itself and then multiply that by 14. Don't worry if this sounds complicated now. Let's break it down. Essentially, what you are doing is saying firstValue equals firstValue times 14. So, it will take the value stored in the variable firstValue, which is 10, then it will multiply it by 14, and then store the result back in the variable firstValue. You can repeat this process using the same code excerpt this time, just adding the value of 1 to get 141. Next, let's move on to compound assignment operators, which is a shorthand way of performing some of the operations that you have learned about already. Compound operators work out the answer and store it in the variable. For example, instead of writing firstValue equals firstValue plus 2, you can just write firstValue plus equals 2. This also works for subtraction, multiplication, and division. In short, compound assignment operators allow you to write more efficient code. Okay, let's move on to mathematical operations with floating point numbers now. You will explore an example where two floating point numbers are added. Suppose that the firstValue variable is assigned an initial value of 3.3. Recall that this will be inferred by Swift as a double. Now, using the same modification sequence you learned earlier, let's assign firstValue to be the value of firstValue plus 1.5. This will now store the value of 4.8 in firstValue. Finally, you can have an example of a division where 20 is divided by 6, returning a result of 3.3 in the firstValue variable. Now that you can perform some basic mathematical operations on integers and floating point numbers, let's explore another operator that developers use frequently, the modulus operator. The modulus operator returns the remainder. You may recall learning this at school. For example, 10 divided by 3 was 3 remainder 1. Let's say, for example, you have a basket filled with 10 apples. If you share the apples evenly between 2 people, there will be no apples left. But if your basket has 11 apples, 1 apple would remain. If you take this example and create a variable called basket, you can say that basket is equal to 10 modulus 2. This will divide 10 into 2 and return a value of 0. This means that no apples remain. The basket is empty. Whereas if you divide 11 by 2, you will get a remainder of 1. Modulus is quite useful for checking if things fit exactly, because you will receive a 0 value if they do. Swift follows the rules of mathematics, and you may recall learning the acronym BIDMAS when you were younger. This represents the order of brackets, indices, division, multiplication, addition, and subtraction. Brackets have the highest priority, while subtraction has the lowest, and Swift follows those rules. Now let's explore working with positive and negative numbers. In Swift, you have something called the unary minus operator. This allows you to convert a number from positive to negative and vice versa. You do this by prefixing or placing the minus operator before a value. For example, if you have let 1 equals 1, you can say let negative value equal minus 1. Negative value will now have a value of minus 1. Finally, let's explore numeric type conversion in Swift. Recall that you learned that Swift is a strongly typed language, which means that Swift uses type inference to determine the initial type of all your variables and constants. So, what would happen if you tried to combine data types such as int and a float? For example, if x has a value of 5, y has a value of 0.33, and z is equal to x plus y, the operation will fail to compile and produce an error. This is because Swift infers x's value as an int and y's value as a double, and different types can't be added together. To solve this issue, the variable x needs to be converted to a double. You do this by passing the variable through an initializer, which will create a new version of the variable x, which can then be added to y. So you have let z equal double x plus y. However, if you have let x equal 5, let y equal 0.33, and let z double x plus y, x will now have a new value of 5.0. That happens because x is inferred as a double. It is very important to keep this rule in mind when you program in Swift. You now understand how operators, compound assignments, mathematical ordering, and numeric type conversions work together, bringing you one step closer to understanding the fundamentals of programming in Swift. Best of luck with the rest of your Swift programming journey. No matter what type of application you create, you will most certainly work with text or characters to display some information. For example, airline booking codes, license plate numbers, or even just plain text with emojis on a messaging application. In Swift, this type of information is represented using the string type, and in this video, you will learn about strings and how to use them in your code. By the end of this video, you will know about the concepts of literals and mutability, and learn how to manipulate and compare strings. First, let's begin focusing on what developers mean when they use the term string. You can think of a string as an ordered collection of characters surrounded by double quotes. For example, the string, hello there. In Swift, strings are represented by the string type and are Unicode compliant. Don't worry too much about the term Unicode for now. Essentially, this is just a unique number that computers use to reference each character or symbol. This means that you can even use things like emojis. Strings are commonly used everywhere in programming, especially when you need to work with text. One example is the comments you make on social media. Okay, so now you know what a string is, let's explore the concept of the term string literals. This is the actual group of characters surrounded by double quotation marks. For example, suppose you declare a constant named myString and assign it the string value of hello world. In this example, the literal is the open double quotes, hello world, close double quotes. Notice that the string is stored in a constant. Swift is also clever enough to store that constant as a type string, so you don't need to tell it. Next, let's explore the concept of string mutability. If you assign a string to a constant, then it is immutable, which means that it can't be changed or modified. For example, suppose you create a constant and assign it a string value of hello world. If you try to reassign this constant to something like hello there, you will get an error in your code. However, if you were to instead assign that string to a variable, the string is said to be mutable, which means that it can be changed. Okay, let's move on to combining strings now. This process is also known as concatenation and is performed using the plus operator. You may recall learning about the plus operator earlier and how it can be used to perform calculations with numbers. Well, the plus operator can be used to perform similar actions with strings. It allows you to take two strings and combine them. For example, suppose you create two variables, string A and string B, and assign them the string values of hi and there, respectively. So, you have let string A equal hi and let string B equal there. Using the plus operator, you can combine or concatenate these string values and then store this result in a new variable named newString. So you write let newString equal string A plus operator string B. Now the phrase hi there is stored as one string in the newString variable. Next, let's explore how you can compare strings. This can be done using two types of equality operator known as prefix and suffix. Prefix checks the beginning of the string and suffix the end. Let's explore this in a little more detail now. Before you continue, it's important to note that checking the prefix and suffix uses a functionality known as methods that you can apply to the strings. Essentially, these methods are a predefined set of instructions that return a result. Don't worry too much about understanding methods right now. You will learn more about them later. For now, just focus on how you can use these built-in methods called hasPrefix and hasSuffix to compare strings. Okay, so suppose you create a variable called quote and assign it to a value of hello world. Let quote equal hello world. Next, you want to check if this string starts with the character h. You can then use the hasPrefix method to check if the string value begins with the character h. So you type quote.hasPrefix h in quotes and within parentheses. Since this is correct, the Boolean value of true is returned. The same applies to the suffix method. If you were to say that quote.hasSuffix or ld, which is the end of the hello world string, it will also return true. It's important to note that the values that these methods check are case sensitive. So, if the value began with a lowercase h, the result would return false. Methods are a powerful tool in programming and provide us with a wide variety of functionalities. For example, you can also convert strings from uppercase to lowercase and vice versa using the methods uppercased and lowercased. Suppose you create a variable called aString and assign it the string value of hi there using capital letters for h and t. Next, you create another variable called upper and assign it the value of aString variable with the uppercase method appended, which is just another way to add to the end. For this, you type let upper equal aString dot uppercased open and close parenthesis. This now means that the string hi there will be converted to all uppercase characters and stored in the variable upper. The lowercase method works in the exact same way, except all the text would be converted to lowercase. Another popular use of methods with strings is counting the number of characters in a string. This can be performed using the count method. Once again, you will learn more about the count method later. For now, just focus on how the count method returns the number of characters in a string. For example, suppose you create a variable named aString and assign it to a string value of hi there. You can then create another variable called the count and assign it the value of the variable aString appended by the count method. So your code is let the equal count equal string a.count. In this example, the variable the count will store the value of 8. This is because the string contains 7 letters and a space, so 8 characters in total. Finally, let's explore how you can create multi-line string literals. When programming in Swift, you can't create and store blocks of text in the same format as you would when typing in a text editor. For example, if you were to create a variable and assign it to a multi-line string using double quotes, you would get an error. To create a multi-line string, you need to use multi-line string literals. Instead of starting with a double quote, you put 3 double quotes and then type the text in the formatting that you want, including spacings and indentations. You then finish with 3 double quotes at the end. If you print this out, it will print exactly as it is formatted in the code. This process is known as what you see is what you get, or WYSIWYG for short. In this video, you learned how to work with strings in Swift. You learned about the string type, literals, mutability, concatenation, and how to work with string methods to perform actions such as compare and count. You can find out more information on strings from the additional reading at the end of this lesson. By now, you are probably familiar with the Boolean type, which returns a value of either true or false. And you are also familiar with the concept of operators, which allow you to perform operations on values. For example, you use assignment operators to declare variables and arithmetic operators to perform calculations on numbers. In Swift, logical and comparison operators return a Boolean result of either true or false. And in this video, you will learn how developers use them to program decision-making in their code. Let's now explore some of these operators, starting with the comparison operators. The first comparison operator is called equal to and is represented by 2 equal symbols. When you use this operator, a Boolean value of true is returned if the value on the left is equal to the value on the right. If they are not equal, a value of false is returned. The next operator is called greater than, and once again, this remains true if the value on the left is greater than the value on the right. Likewise, the less than operator works in the same way, except it checks that the value on the left is less than the value on the right. Next is the greater than or equal operator, and this performs 2 checks, that the left side is greater than or equal to the right side. And the same logic holds true for the less than or equal operator. It's important to learn these operators as developers use them frequently. The next operator is the opposite of equal to and is called not equal. This is expressed using an exclamation mark and an equal symbol. This returns true if the 2 sides are not equal to each other. However, if they are equal, then it will return false. Okay, now that you have learned about comparison operators, let's cover logical operators. Developers use them in decision-making to check whether an expression is true or false. The first logical operator is called the logical AND operator. It is used to check if 2 sets of values or groups have anything in common and is often used for ranges of values. For this operator to return true, all expressions must be true. Say you're logging into your account. The system checks if the email is on file, and then it checks if the password you provide is the same one for the account. If both conditions are true, then you are logged in. The next operator is the logical OR operator. This means that only one of the 2 values must be true for the overall expression to be true. If neither value is true, then false is returned. The next operator is called NOT, and this basically just inverts the Boolean value. For example, it changes anything that is true equal to false or anything that's false equal to true. In other words, it changes it from true to false. The last operator is known as an advanced operator. It is only used in specific circumstances, and it is called exclusive OR. Exclusive OR states that you can use either one thing or the other, but you can't use anything that's common to both. For example, if you were to type 5 exclusive OR 10, then anything between 5 and 10 could be used, but anything outside of those values could not. Now, the nice thing about it is that it is its own inverse, and because of this, it has a number of different uses in computing, such as encryption. You may have heard the term encryption when paying for something online. Essentially, this is just the process of converting the information to scrambled code so that it cannot be unlawfully decoded by someone else. In this video, you learned about some of the different types of operators in Swift, such as the comparison and logical operators. You also learned how these operators return a Boolean value of either true or false. Developers work with Boolean operators frequently, especially when making decisions and creating code for conditional statements. You will learn about conditional statements later. If you would like to learn more about operators, there is a link from the additional reading at the end of this lesson. Every day, from the moment you wake up, you make decisions. From what clothes to wear, whether to have tea or coffee for breakfast, or even what movie to watch. While some decisions are complex, some can be relatively simple, and you make them based on whether some condition is either true or false. For example, If it's raining outside, you will likely bring an umbrella. The condition here is the weather. If it's raining, you take an umbrella. If it's not, you don't. In this video, you will learn about the if statement, the if-else statement, and how Booleans and logical operators are used in conditional expressions. In Swift, there are pieces of code called conditionals, and developers can use them to run code based on whether the condition is met. Using these statements, developers determine how they are going to execute the code. There are many types of conditional statements, but the first one you will learn about is called the if statement. The if statement checks a condition and executes a code block inside curly brackets if the condition is met or true. If the condition is not met or not true, the code is not executed. The condition criteria are essential here. The block of code is only executed if the condition is evaluated to the Boolean value of true. You can use different types of comparison and logical operators to evaluate the condition, and you may recall learning about them in a previous video. These operators include equal to, greater than, less than, and not equal to. Now let's explore a scenario where you need to print a statement based on the temperature of the water to check if it's freezing, which happens at 0 degrees Celsius. First, you declare a constant named water temp and assign it a value of 0, the freezing point. You write let water temp equal 0. Next, you create a conditional statement, which is the if statement, and use the equal to operator to check if the value of the variable named water temp is equal to 0. You type if water temp, two equal symbols, 0. If this condition is satisfied or true, then the code block inside the curly braces is executed. In this example, it's a print function to print the text, the water is freezing. Since this condition is true, the print function is executed and outputted to the screen. Now, if you want to run some other code when the condition is not satisfied or false, then you can use an else statement, which follows the if statement. Notice that the else statement does not have a condition associated with it. Its purpose is to execute code when the criteria for the if condition is not met. Let's use our check water scenario again, but this time to check if the water is boiling or not, and print out the appropriate statement. Water boils at 100 degrees Celsius, so in this scenario, you will check if the water temperature is greater than or equal to 100. First, you declare a variable named water temp and assign it a value of 92. So you type let water temp equal 92. Next, you create an if statement. If water temp is greater than or equal to 100 and open curly brace to check if this condition is true. If this condition is satisfied or true, it executes the next command. Print the water is boiling, which is inside the curly braces. However, the water temperature is 92 degrees, which means the condition is not met and the print function is not executed. So how do you print a message saying that the water is not boiling? You can use an else statement, and the code inside the else statement is executed when the if condition is not met or false. Then the print function, the water is not boiling, inside the curly braces of the else block is executed. Since the value of the variable water temp is less than 100, the criteria in the if statement is not met, so the else block of code is executed, and it prints the statement, the water is not boiling. So far, you've learned about using conditionals based on one or two criteria. However, in the world of programming, things are often not that simple. Sometimes you need to check across multiple conditions, and to do this, you use the else-if statement. Using the else-if statement, you can nest multiple if statements to test many conditions that depend on each other. The last else is used to catch all the other remaining outcomes. For example, suppose you want to create some code to check where you finished in a race and print the result. The code checks against a value stored in a variable named position. It reads var position equals 2. Then it checks. If position equals 1, print you came first. Then you have an else if. Else meaning your position is not 1, and if to check if position equals 2. If this is true, then print you came second. And finally, a second else statement meaning your position is not 1 and not 2. If you did not finish in the top 2, you just receive a message saying you did not finish in the top 2. Let's cover this in more detail. First, you create an if condition to check if the value stored in the variable position is equal to 1, and if true, print the result. Second, you create an else if condition to check if the value stored in the variable position is equal to 2, and if true, print the result. Finally, you create an else block to execute the code that is not satisfied by the first two conditions. Since the value stored in the variable position is 2, the else if condition is satisfied, or true, and its block of code runs and prints, "You came second." The important thing to remember here is that with conditional statements, Swift will keep checking until the criteria is true or until it reaches the end. Okay, let's switch to how you can use Boolean operators with your conditional criteria. Using Booleans, you can test if something is true or false. You can do this creating a variable cold outside, for example, and writing something like if cold outside equal true print, put on a warm coat. It's also possible to rewrite the conditional criteria for Booleans by omitting the equal to operator. This is because both conditional criteria must satisfy to either true or false, and Boolean values can only contain true or false. So you can just write if cold outside, print, put on a warm coat. Next, you can use the logical AND operator to combine multiple Boolean expressions. You may recall that the logical AND operator returns true if both sides of the expression are true. For example, you can check the range of the temperature of water and print the result using an if-else statement. First, you write var temperature to declare the variable and then assign it a value of 69. Then you check if temperature greater than or equal to 68 and temperature less than or equal to 72, print, the temperature is just right. Else, print, the temperature is too hot or too cold. Likewise, you can use the logical OR operator, which returns true if one of the sides of the expression returns true. For example, suppose you have two variables, mains power set to false and battery power set to true. You can use an if-else statement to print whether either you can use your device or better find a charger. The if statement checks if mains power or battery power, then I can use my phone. The criteria here in the if statement uses the logical OR operator to check if either variable is true, and the else statement prints better find a charger when both conditions are false. Since the variable battery power is true, the if condition is satisfied and its block of code runs and prints, I can use my phone. In this video, you learned about the conditional statements if, else, and else if. You also learned how to use operators in your condition criteria to evaluate and check for true and false. Conditional statements are a powerful tool and one of the fundamentals you need to master when programming in Swift. Every day, you wake up, you eat, and then you go to sleep. And the next day, the cycle repeats. The end is connected to the beginning, much like a loop. In programming, a loop is used to repeat a block of code. In this video, you will learn about the 3 different types of loops used in Swift and how they can be used to perform repetitive tasks. These are the for-in loop, the while loop, and the repeat while loop. Remember the example conditional if statement that checked if the water temperature was 0 degrees? It printed, the water is freezing, if the condition was met. This sequence only runs once. What if you needed to do this multiple times? Well, to do this, you need to use something called loops. In Swift, developers use loops to continually execute repeated blocks of code until a certain condition is satisfied. Loops are similar to conditionals in that a condition must be satisfied in order for the code to execute. Each type of loop is used in different circumstances. The for-in loop is used for repeating an iteration for a set number of items. For example, you want to eat a pancake every day for the next 7 days. The while loop is used when a specific condition is true. You want to eat a pancake only on the days it is raining. And finally, repeat while loop is used in situations where you need something to run at least once before checking if the condition is true. For example, you eat one pancake, then before you eat another, check to see if it's raining. Pancakes aside, let's explore each loop in a little more detail. Okay, so you've learned that a for-in loop is used when you need to loop a definite number of times, when you know upfront exactly how many times something needs to repeat. The for-in loop performs a set of statements for each item in a range, sequence, or collection. So, for each item in a range, the for-in loop body is executed. Once the last item is checked, the loop will terminate. Don't worry if you've not heard about collections yet. You will learn more about them later. For now, let's explore the structure of the for-in loop. For example, suppose you want to create a loop that will print the numbers from 1 to 5. You will want the loop to run at least 5 times. In Swift, you can provide the range that the for-in loop must complete. First, you start with the keyword for, and then some variable name, followed by the keyword in, and then finally your range. The range consists of a starting value, 3 dots, then an ending value. The 3 dots tell Swift that the loop must start at the first number and run until it reaches the second number. The number of times is counted by the value in the syntax. The body of the loop contains the code to be executed, and it is placed inside a set of curly braces. When this loop runs, the value is equal to the starting number in the range, which is 1. Every time the loop runs, 1 is added to the value, so the loop runs until the value is equal to the last number in the range. For example, you can have for value in 1 dot 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 5, then a print function inside the loop. In this case, the loop starts at 1 and stops at 5. Where for-in loops are used for an exact number of times, while loops will continue looping as long as the defined condition is true. Each time it goes around the loop, it will check that the condition is still true. The loop will be terminated when the condition is false. For example, suppose you're designing a game where players have 3 turns to make a move. First, you create a variable named turns and assign it the value of 1. var turns equal 1. Next, you create a while loop with the condition that the value of the variable named turns must be less than or equal to 3. So you type while turns less than or equal to 3. In the body of the loop, you print the turn number. Print this is turn number. Finally, you increment or add the value of 1 to the turns variable. Turns plus equal 1. The loop will continue running until turns is less than or equal to 3, and then it will terminate. If you want to show the player how many turns they have left, this can be achieved by using what is called a flag. So, you may have a variable called total turns, which is equal to 3, and a second variable called turns left that is equal to true. So your code reads var total turns equal 3, var turns left equal true. You can use a flag in your while loop to change turns left to false when there are no turns left. You then set the condition of the loop to be the value of the turns left variable by typing while turns left. Inside the loop, you decrement the total turns variable in each iteration, total turns minus equal 1. And you set a condition to change the turns left variable to false if total turns is less than 1. If total turns less than 1, turns left equal false. This will terminate the loop when the player runs out of turns. As long as the condition returns true, the loop will continue and print, got another turn. Flags are especially useful when you want to set a value to true or false to end a loop. Now, what if you wanted to create a statement that is executed at least once before checking if a condition is true? In Swift, the repeat while loop allows you to achieve just that. Like the while loop, the repeat while loop will continue looping as long as a condition is true. However, it first runs the body of the loop and only then evaluates the condition. The condition is always checked after each loop is executed. If the condition is true, the code block is executed again. The condition is then evaluated once more. This process continues until the condition is false. Only then will the loop terminate. In a real-world scenario where you may need data from a user up front, the repeat while loop can be used to show them the information you require before they can continue using the service. In this video, you learned that for-in loops are ideal for situations where you know how many loops there are going to be. While loops are best used when the number of iterations are not known before the first loop begins. And finally, repeat while loops allow you to run an iteration at least once before evaluating the condition. Previously, you were introduced to the use of loops in Swift. Let's add another layer to it and look at what nested loops are. In simple terms, nested loops are when there is a loop present inside the body of another loop. Let's start by looking at the syntax and skeleton of nested loops. In this code, I have created an inner loop within an outer loop. In this example, the I is iterating from 1 to 10 and is part of the outer for loop. This means it will iterate 10 times in total. Similarly, j is iterating from 1 to 5 and is part of the inner for loop. I can also do this for while loops. On my screen is another piece of code written previously. The errors displayed are because there is no condition keyword. I use condition purely for demonstration purposes. The functionality of the while loop is different from that of the for loop. The way the inner loop and outer loop function is the same. I can also combine these types of loops in a nested loop. On my screen is a piece of code I have written previously. Firstly, I create a variable with the name month and assign it the value of 1. In the outer loop, I first check if the value of month is less than 4 using the while loop. In the inner loop, I use the for loop for iterating the value from 1 to 4. For each loop, I am printing an output. Lastly, I am incrementing the value of month so I can exit the while loop when the value of month is more than 3. Let's run the code. In the output, you can see that the month, which is part of the outer while loop, is the first line in each of them. This is followed by the 4 statements of the inner loop. The same sequence occurs while the value of the month is equal to 4, in which case the outer loop exists. In each of the cases, the inner loop goes through its complete iteration from 1 to 4. This is evident from the count in the output. Different iterations can be created just using the for loops, the while loops, or a combination of them. Now let's look at 2 keywords used in control flow, namely break and continue. Break is a keyword used to break the flow of the loop immediately, irrespective of the preconditions that are set in the conditions. If the break is used inside an inner loop, it will exit the inner loop. For example, I can add if I equal to 3 in the inner loop and press enter. On the next line, I add the keyword break. When I run the code again, you can see in the output that the count is now only 1 and 2. The condition will break when the value of I is 3. Similarly, if the break is used in an outer loop, it will complete the cycle of the inner loop before it exits the outer loop and effectively exiting the nested loop altogether. The continue keyword is also used to alter the control flow of your program. Continue is used in cases where you want to skip the current iteration of the loop. This way, the control flow continues execution and jumps to the next iteration of the loop. I clear the break statements from my code and then add if I equal to 2 in the inner loop and press enter. On the next line, I add the continue keyword and run the code. In the output, each iteration where the value of I is 2 in the inner loop is kept. The concept of nested loops is fairly straightforward, but has a wide variety of applications in Swift and all programming languages. When it comes to programming, crashes are often inevitable. However, most programming languages have preventative measures in place. With Swift optionals, you can separate the good code from the bad to prevent unintentional events from happening in your programs. As you have learned previously, constants and variables must always have a value or reference stored inside them. If you try to run your code otherwise, the program will likely crash. Now, what if you needed to signal that the value or reference to an object may or may not exist? That it is absent and not yet defined? Well, this is where optionals come into play. Optionals indicate that a variable either has a value and it equals x, or there is no value at all and it is empty. In such cases, the optional will return a value of nil. Nil is a special literal that tells Swift that a value is absent. So instead of the absence leading to undesirable patterns in your code or a crash in your program, Swift recognizes the optional as a safeguard for an undefined value or for a situation where certain outcomes can't be guaranteed. If this sounds a bit complicated, you can think of optionals as a wrapper used to hold something, like chocolate, for instance. So, either the wrapper has chocolate in it or it's empty. In the Swift programming language, optionals are wrappers that hold specific types. This means that you can wrap an instance in an optional to hold a value, or leave it empty. In essence, optionals help developers create better domain models that can handle cases where certain relationships or associations may not be present at a given time. Now, the next two concepts you will become more familiar with as you progress through this lesson are called forced unwrapping and optional binding. Forced unwrapping allows you to extract a value from an optional, while optional binding describes the process of determining if the optional contains a value, making it safe to use as a temporary constant or variable. This video provided you with an introduction to optionals on a foundational level. You will find that the upcoming lesson items provide a more in-depth view on how optionals are declared, unwrapped, and used in Swift. For now, all you need to remember is that optionals help developers like you make your code safer and more expressive by signaling to Swift that the value of a variable may be absent. In this video, you will learn about optionals and explore the concepts of nil, forced unwrapping, optional binding, and implicitly unwrapped optionals. First, let's start by declaring an optional. To declare an optional, you add a question mark or an exclamation mark after the type. For example, suppose I declare two variables named a value and b value as integers. To indicate that they are optionals, I add a question mark or exclamation mark after the type. When I print these, the console output is nil in both instances. Notice that the code executes, but with some warning messages. Don't worry too much about this for now. The program continued execution without an error. You use the question mark to indicate to Swift that the value it contains is an optional. And since this is an optional int, it will either have an integer value or no value such as nil. The exclamation mark in Swift usually acts as a warning sign. It is like a cautionary indication that you may be dealing with something that can potentially backfire. Next, let me demonstrate a process known as unwrapping optionals. Before that, let me delete the variable named b value and the print statement associated with it. Since optionals are conceptually wrapped inside a container, the value can only be accessed directly using the exclamation mark operator. For example, let me create another constant called b value, declare it as an int, and assign it the value of the variable named a value. Now, if I try and execute this code, it will cause an error. To solve this, I can add an exclamation mark at the end of the optional, and this process is known as forced unwrapping. This means the value is unwrapped irrespective of the contents. However, this also generates a runtime error, which simply cautions and stops the execution. Forced unwrapping must be avoided unless there is certainty that the optional statement contains a value or is not empty. To avoid this scenario, you can use something called optional binding. This is a type of safety check performed before the assignment. It's achieved with the help of the if-else statement. Okay, before I demonstrate this, let me delete this last line of code. To create optional binding for the code above, I use the if-let-else statement and set the conditional criteria to be the variable a value equals a value. Then inside a set of curly brackets, I can place a print statement to output the value of the variable a value. Next, I create an else statement where I print a string that says no value. Let me run the code again and notice that the string no value is output. And this is expected as I know that the value of the variable a value is nil. In this example, using the if-let-else statement unbinds the optional by storing a non-nil value in the local variable. Note here how this temporary variable name can be the same as the optional that has already been declared. Another way is to use implicitly unwrapped optionals. Remember that optionals indicate that a constant or variable is allowed to have no value. In some cases, however, the value for the optional is set early in the code, and there is no need to check and unwrap a value every time, as you already know there will be a value present. In such cases, you use something called implicit unwrapping. As the name implies, there is no extra step you need to take to unwrap these type of optionals. Let me demonstrate this now. I'll clear code from the playground and once again declare two constants, a value and b value, as ints. However, this time I assign them respective values of 5 and 3. For the variable a value, I will place a question mark after the int keyword, and for the variable b value, I will place an exclamation mark. Finally, I will use the print statement to print both of these variables. Notice that when I run the code, the variables are output to the console. Both of these are valid optional syntax and can be seen wrapped in the output. Developers mainly use this when they need to communicate to things in iOS. The implicitly unwrapped optional acts as something called a promise. Don't worry too much about this for the moment. For now, you can just think of it as a useful feature, for example, when building apps on iPhones. You can still treat an implicitly unwrapped optional like a normal optional to check that it contains value. So to recap, optionals are used if a variable or constant could potentially be empty or have no value. You declare an optional with either a question mark or an exclamation mark. You can use the if-let-else statement to check if the optional has a nil value. Finally, if the value for the optional is set earlier in the code, you can implicitly unwrap it. Understanding optionals is an important skill for aspiring developers, as its common features are used throughout Swift. You've reached the end of this module on programming in Swift. Over the course of this module, you learned about general programming principles and how to apply them in Swift. You were introduced to data types, variables, conditionals, loops, and optionals. It's now time to recap the key lessons you learned and the skills you've gained. You began the module with an introduction to programming in Swift and a tour of the Playground UI. You then moved on to learn about constants and variables and discovered that constants store fixed values that cannot be changed once defined, while variables allow values to be modified. You also practiced declaring constants using the keyword let and var for variables, and demonstrated your ability to use constants and variables to store information. You also explored how the print statement outputs information to the console and practiced creating your own. In addition to learning about constants and variables, you were also introduced to different data types like strings, integers, and floating points. You explored how Swift automatically detects the type of data you want to work with by using type inference. You also learned how to perform basic mathematical operations on data types, how to work out an answer and store it in the variable using compound assignments, and how to combine data types using type conversions. Next, you moved on to learn about strings in more detail. You discovered that strings are an ordered collection of characters surrounded by double quotes, and that they are used to store text values in constants and variables. And as you may recall, the group of characters enclosed in double quotes is called a string literal. You then moved on to learn about string mutability, which unpacked the different use cases for constants and variables. Thereafter, you explored how to combine strings using concatenation and discovered how the prefix and suffix methods allow you compare elements of a string. Following your exploration of strings, data types, and variables, you were then introduced to if and if-else conditional statements. You learned about Boolean values and how developers use them to program decision-making in their code. And then you learned about comparison operators and how they are used to compare data types to produce a value. And finally, now that you've reached the end of this lesson, you know what optionals are, and you are now able to distinguish between forced unwrapping and optional binding. You're now familiar with the basics of programming in Swift. You can explain how to use variables, strings, conditionals, loops, and optionals. That's a great start to your Swift development journey. Well done. You probably know that freight trains are an important means for moving cargo, but have you ever thought about the system that keeps things running smoothly as changes are made at every stop? Carriages are typically set in a specific sequence, and each carriage may carry different items or materials. Other carriages can also be added or removed without disrupting the rest of the order. Much like a freight train, Swift has a piece of functionality that allows you to store and rearrange sequenced collections of items. This is called an array. In this video, you will be introduced to the concept of the array collection and how it is used to store data. You will also learn how to edit an array, how to use methods and perform operations such as append, insert, and remove items in arrays. Let's say that you want to emulate a toy freight train using Swift. On this train, each carriage has a number painted on its side and is presented in sequence, starting from 0. Using Swift, you'll assign some cargo value to each carriage and store it in a variable. First, you declare a variable named carriage 0 and then assign a string value of wheat. Great! Now, when you print the variable carriage 0, the word wheat is output. You can use the same approach to model your entire train. Let's say you do just that and end up with 5 variables of different values. For example, var carriage 1 equal barley, var carriage 2 equals salt, and so on. Wonderful! You've just built a train with 5 carriages, each holding different cargo. Now let's make things interesting and introduce a second train. This one only has 2 carriages, with the numbers 0 and 1 painted on the sides. Seems pretty simple, right? Well, now you can't use the variable names carriage 0 and carriage 1 because they're already in use by your first train. You could try and use more descriptive names, such as train 2 carriage 0 and train 2 carriage 1, but now you are complicating your code. Another problem is that you need to signal that these variables are a collection belonging to train 2, but when written this way, Swift doesn't understand that. Luckily, you can fix this. To make Swift understand that you want to group a sequence of variables in a collection, you use arrays. Arrays store ordered lists of value of the same type. Swift arrays are specific about the kinds of values they can store, and you can do this by specifying the type or by allowing Swift to do it by type inference. For example, you can create an array of integers, floats, or strings, but you cannot mix them. You can build an array using the array literal syntax, which is written as a list of comma-separated values surrounded by square brackets. To store an array, you assign that collection to a variable. For example, var train1, followed by a colon, and the type of the value, string, within square brackets. Notice that in this case, the data type of string is declared. Then, you can add items to the array by typing the item names, making sure to separate each by a comma, and enclosing everything within a pair of square brackets. In this case, each item is in double quotes because they are string types. Once again, you can also let Swift determine what type the array is using type inference. So you do not have to declare the type of array to be stored. So you can just write var train1 equal without specifying the type of the item in the array. Okay, so now you know what an array is and how to create an array. Let's now explore how you can access values in an array. Do you remember how you built a train with carriage numbers? Well, in Swift, this numbering system happens behind the scenes. This is known as the array index, and you can then use these index numbers to access each array item. Swift gives each array item a number starting from 0 that corresponds to its place in the sequence. Remember that in the example you had var train1 equal wheat, barley, potato, salt, rock. So wheat is index 0, barley index 1, potato index 2, and so on. To output the array item located at index 0, you would create a print function and inside the parenthesis type train1 followed by 0, encased in square brackets. This will access the first value of the array named train1, which is wheat. Okay, so now you know how to access array values using the index. Let's now find out how you can add, edit, and delete items from an array. Let's start with editing an array value, and to do that, you use the assignment operator. To edit the array item, you specify the item index value and then use the assignment operator to change its value. For example, if you have an array with 2 items, wheat and barley, and you want to change the value of the second item, you can have train1 and the index number 1 within square brackets, then equal, and sugar within double quotes. Once again, it's important to remember that the value you change it to must be the same data type. Now to add and delete array items, you need to use something called array methods. They are like some of the methods that you have learned earlier. For example, do you recall using the count method to count the number of characters in a string? It was something like printName.count. Well, you can use the same count method on an array to return the number of items in the array. For example, you can declare an array var train1 equal wheat barley. Then you can use a print function, printtrain1.count. This statement will return 2 because there are 2 items in the array. You also have specific array methods such as append, insert, and remove. Let's explore them briefly now. You can use the append method to add an item to the end of the array. For example, train1.append salt adds salt to the array. And if you want to add another item to the array, you type train1.append rocks. Now your array has 4 items. You can also add an item to an array using the insert method, but you must specify the index and the value of where you want to insert it. For example, you can add an item by typing train1.insert potato, @:3. This will insert the item potato after the 3rd item in the array. Finally, to remove an item, you can use the remove method. Here, you just need to specify the index of the item you want to remove. For example, if you want to remove the 4th item, you type train1.remove @:4. To summarize, arrays help us achieve several things in Swift. They signal that the assigned values all belong to a group. These values are ordered in a sequence and must be of the same data type. Each array item can be accessed through its index number. And you can use array methods to add and delete items from an array. In this video, you discovered how arrays are used to store multiple values of the same data type in an ordered manner using index values. You also learned that you can store any type of element in arrays, like integers, floats, and strings. Arrays carry values like a freight train carries goods. They store and collect information that you can use in various ways. Suppose you are having a picnic and prepare 2 different baskets, one for food and another for drinks. Each basket is half empty, so instead, you decide to put everything into the one basket. If you were to represent this in programming, an example might be that you are combining 2 arrays to create an array of mixed types. In this video, you will learn how to add 2 arrays of the same type together, then explore how to use different data types within an array. Finally, you will learn how Swift provides you with 2 different types that help you work with an array of mixed data types. Recall that you can store multiple values of the same type using something known as an array. Well, in Swift, you can also create a new array by adding together 2 existing arrays of the same type. Let me demonstrate this now. Okay, so I'm in Xcode and notice that I have 2 arrays that I created previously. A array with integer values of 1, 2, 3, and B array with integer values of 4, 5, 6. To combine the 2 arrays, I can use the plus symbol to add them together. First, I create a new constant named C array. After this, I add a colon and then define the type as integer inside the square brackets. I then assign this array to be the values of A array plus B array. Next, to print the output of this array. On the next line, I type the print function and place C array between the parentheses. Finally, I click the Run button to execute the program. Notice that the output of 1, 2, 3, 4, 5, 6 displays at the bottom of my screen. This is a combination of A array and B array as they are of the same type. It's important to remember that arrays, by default, are set to handle a specific type, for example, integers. However, what if you wanted to work with an array of mixed types? Well, Swift has 2 special types that allow you to work with non-specific types, namely any and any object. Don't worry about the type any object for now. You will learn more about this later. For now, let's just focus on the any type. Any can represent an instance of any basic type, for example, strings, integers, and doubles. This allows you to create an array of mixed types. To demonstrate this, I'll create an array with mixed types. First, let me clear my screen. Okay, so to create an array with mixed types, I type var, then the name of the array I want to create, like an array, followed by a colon. Then Between square brackets, I define the type as any. After this, I add an equal sign and the number 59 between square brackets. Notice that this value is of type integer. On a new line, I can add a new value of type double to the array by using the append method. To do this, I type anArray.append and place the value of 3.33 between the parentheses. On the next line, I add another array item of type string by typing anArray.append. I enter the string orange, enclosed in quotation marks, between the parentheses. Finally, to output the array values, on a new line, I type print followed by an array placed inside the parenthesis. OK, so I'll run the code again and notice at the bottom of my screen the output is 59, 3.33 and orange. Notice that this is all the types that I have created: an integer, a double and a string. It's important to understand that while you can create an array with multiple data types, it might not be the most optimal way to structure your data. In Swift, there are other options available to achieve this, and you will learn about them later. However, there may be some situations where this can be required. For example, developers building mobile apps with iOS. In this video, you learned about how to add two arrays of the same type together and how to use the type any to work with an array of mixed types. In this video, you will learn about tuples, which are used to store multiple values of different data types. Developers use tuples when they want to assign a variable with multiple values or return multiple values from a function. Tuples are useful for temporary groups of related values. They are not suited to the creation of complex data structures. In an earlier lesson, you learned that you can store multiple data types in an array using the any data type. For example, suppose I wanted to create an inventory for a restaurant using an array of food items. I can do this by creating an array that can hold three data types: a string, an integer, and a boolean. First, I type the keyword var and the variable name vegarray, followed by a colon, and then the keyword any inside square brackets, followed by the assignment operator. Next, inside another set of square brackets, I add the string value of caret, the integer value of 3, and the boolean value of true. Notice that these values are separated by a comma. While this will work, arrays are not always best suited, so another option is to use tuples. Like an array, a tuple is a list of items, more specifically a comma-separated list of items, enclosed in parentheses. I can create a tuple and assign it to a variable by typing the keyword var and the variable name vegetable, followed by the assignment operator, and then I create a set of open and close parentheses to place the tuple values. Next, inside the parenthesis, I add the string value caret, the integer value of 3, and the boolean value of true. Again, notice that these values are separated by a comma. Tuples are especially useful because they can be passed into things like functions to return multiple individual values. Okay, so let me delete the line of code with the array now. So, once you have declared your tuple, you might need to extract its individual values. This is known as decomposing a tuple, and there are a couple of ways to do this. To decompose a tuple, I can assign its elements to individual variables. To do this, I start by typing the keyword var, and then inside parentheses, the variables of vegtype, quantity, and in stock. Next, I use the assignment operator to assign these to the tuple. Now I can use the print function to print a value stored in my tuple, such as quantity. When I run the code, it builds the playground and returns a value of 3. Another way to do this is to create a tuple with named parameters. To demonstrate this, I declare another variable named veg and assign the equal operator to parentheses. Next, inside the parenthesis, I can define the name and value for each element using key value pairs. For example, vegtype, colon, and then caret. Then quantity, colon, and then 3. And finally, in stock, colon, and then true. So now when I add a print function, I can use a key to access and return the value. When I run this code, caret is retrieved from the tuple. Another way that you can access values in a tuple is with the help of indexes. Instead of supplying the tuple name, you can use the index number. For example, veg.0, which will print caret, and veg.1, which will print 3. It's important to note that, like an array, the index begins at 0 and you can't include any indexes outside of the bounds of the tuple. Okay, so now, what if I don't want to extract anything out of the tuple? I can use the same methods as before, but by using an underscore, I can tell Swift to ignore specific values. For example, I type let, and then a space, and then inside parenthesis, I type the underscore symbol, comma, space, quantity, comma, space, and then another underscore symbol. This is then assigned to the tuple named vegetables. Now what happens here is that Swift ignores veg name and instock, but keeps the value of quantity. In this video, you learned about tuples and how they are used to store multiple values of different data types. You learned how to create a tuple, some of the main methods developers use to decompose a tuple, and finally, how to modify its values. Tuples are useful for temporary groups of related values, and developers use them when their values or related values are likely to change or be dropped. You can think of them as a low-cost way of grouping values, rather than the full-on creation of a data structure like an array. Let's say that you are managing an airline miles program and you want to have a list with your clients' names and the number of miles they have. In Swift, you can store this information in a type of data structure called a dictionary. Developers use dictionaries when they need to look up values based on their identifier. A dictionary is a collection of items that have a key and value. The keys must be of the same type, and the values must also be of the same type. As an example, you can have Richie with 500 points, Peter with 400, and Amy with 800. In a dictionary, each value is associated with a unique key, and you use the keys to look up the associated value. In programming, this is commonly known as a key-value pair, which consists of two related data elements separated by the colon symbol. The types of the keys and values must be specified or inferred. Let's unpack this example in more depth. To create and store a dictionary, you start by defining a variable, let's say travel miles, followed by the colon symbol. Next, you specify the data types for the key and for the value. For example, you type the keyword dictionary and then string for the type of the name of the traveller and int for the type of the number of air miles. These types are enclosed by a less than sign and a greater than sign and separated by a comma. Next is the equal symbol, or assignment operator that will store the dictionary contents in the variable. Finally, you can have the name of the travellers and their miles within square brackets. For example, Richie within double quotes, colon, and his miles 500. Then Peter within double quotes, colon, and his miles 400. And then Amy with 800. Notice that in the syntax you start with a square bracket. Then you have key-value pairs separated by comma, and each key is separated from its value by a colon. But, as mentioned before, if the types of key and value are inferred, there is no need to specify them. You do not have to include the part where the data types are specified. So, you just write var travel miles dictionary, the types and the key-value pairs. In Swift, you can use the count property to count how many items or key-value pairs there are in a dictionary. To do this, you can declare a constant with the keyword let. Let's call it item count. Then you assign it the number of items in the dictionary by using the count property. So, you have the equal sign and mydictionary.count. In Swift, you can also create an empty dictionary. For example, var mydictionary equals dictionary, and then the key and value types within the less than and greater than symbols, separated by comma. And finally, the open and close parenthesis with nothing inside, meaning that you are creating an empty dictionary. Once the dictionary is defined, you can access and modify it either by methods or properties or using subscript syntax, similar to how you do it with arrays. Now, let's cover how to add an item to your dictionary. To add a new traveller and their miles, you type the dictionary name, which is travel miles, then the item key, or Daryl, within square brackets, the equal sign, and the number of miles Daryl has, 700. Note that this new item is not added in any particular order in the dictionary. Okay, so what if you want to retrieve the air miles of a traveller in the dictionary? To do this, you must supply a key so that the number of miles is returned. When you supply a key, it may be the case that the traveller is no longer in the dictionary. That would result in an error. To prevent this from happening, you start your code with an if let. So, you have if let, then you declare a variable, traveller miles, equal, travel miles, and Peter in quotes and within square brackets. This code assigns the traveller miles variable the number of miles Peter has, 400. If you try to retrieve the number of miles of a traveller that does not exist in the dictionary, the if-let prevents an error from happening, and the traveller miles variable receives the value of nil. Now let's explore how you can change an item. Again, you can have the dictionary name, which is travel miles, followed by the key of the value you want to change. In this case, recall that Richie exists. To update Richie's miles, you can type Richie in double quotes and inside brackets, followed by the equal sign and the value 1200. You can also set or change an item in a dictionary differently by using the update value for key method. For example, you can start with if-let. Then you add a variable called old value and the equal sign, followed by the dictionary name and travel miles dot update value. Next, within parenthesis, you type the updated number of miles and then for key, Peter. Finally, you print the value stored in the old value variable. Let's now cover how you can delete an item by calling the dictionary's remove value for key method and specifying the key of the item you want to remove. For example, if you want to delete the Richie item, you use if-let again, so it won't return an error if the item doesn't exist, and then a new variable named deleted item. Then the equal sign, the dictionary name, travel miles, dot remove value, and within parenthesis you write for key, colon, Richie in double quotes. You can also remove an item by assigning the value nil to a key. For example, you can type travel miles, double quotes, Richie within square brackets, equals nil. The difference is that in the remove value for key method example, a variable that stored the old value was created. In contrast, you do not store the old value anywhere when you assign nil to a dictionary key, as you did in the second example. In this video, you learned that you can store a key and its respective values in a dictionary. You also discovered how dictionaries make it possible for you to retrieve, change, and even remove items using different methods. In this video, I will demonstrate how loops can be used with collection types. More specifically, I will walk you through the process of using for-in loops with arrays and dictionaries. Recall that you learned that for-in loops are very useful when you know how many times you need the loop to run. Arrays and dictionaries are a case in point, where the amount of items are known, and I can find out how many there are using the count method. The for-in loops are designed to handle both arrays and dictionaries in Swift using a lightweight syntax. Let's explore an example with an array of names again: Harry, Lucas, and Nicola. First, I will define an array by typing let names equal Harry, Lucas, and Nicola. Notice that each name is surrounded by a pair of double quotes and separated by a comma inside square brackets. Next, I use the Enter key to move to a new line where I will insert the for-in loop. I start the for-in loop with the keyword for, followed by a new variable called aname. This variable will store each individual value in the names array, and then I add a print function in a set of curly braces with a string hello, followed by \aname in parenthesis. When I run this piece of code, the names are printed individually. Hello James, hello Lucas, and hello Nicola. Swift is designed to handle the use of for-in loops with arrays very well. Next, let's discover how to use loops with dictionaries. Unlike arrays, a dictionary has a key and a value, which makes the process slightly different. Now, let me clear my screen. Suppose I create a dictionary of vehicles to store the amount of wheels they have. To create the dictionary, I will start by typing the keyword let, followed by the name I want for the dictionary, which is vehicles, and then the assignment operator. Then, I will define the dictionary by inserting keys and their values in square brackets. For instance, double quote, unicycle, close double quote, which represents the key, followed by a colon and a value, in this case 1. Recall that the colon is used to separate the key from the value, and together, this is what is called a key-value pair. Next, I add a comma so that I can insert another key-value pair for motorcycles, which has a value of 2. And then I insert Reliant Robin, which was a vehicle used in the 60s and 70s that only had 3 wheels. Finally, I add a key for car, which is accompanied by a value of 4. To iterate over this dictionary, I first create a tuple which will contain vehicle name and wheel count. I do this by inserting the keyword for, followed by parenthesis. Then inside the parenthesis, I define two new variables, vehicle name and wheel count. So it now reads for vehicle names, wheel count in vehicles. What happens here is that as the for loop goes around, it pulls out a key value pair of the key and the value it owns, and then decomposes it into the two variables defined inside the tuple. So now I can access these within the for loop by typing print a \vehicle name in parenthesis has \wheel count in parenthesis, followed by the word wheels to conclude the string. When I run the code, the different vehicles and the amount of wheels they have are displayed individually. A unicycle has one wheel, a motorcycle has two wheels, etc. And there you have it. In this video, you explored two different examples that demonstrate how Swift makes it straightforward to use for-in loops with arrays and dictionaries. Well done! You've reached the end of this module on data structures. Let's take a moment to reflect on the key concepts you learned about and discuss the new programming abilities you have acquired. You began this module with an introduction to arrays and tuples. In the first lesson, you learned that arrays are like a freight train that stores items of the same type in each carriage. Similarly, arrays are used to store values in an ordered fashion using an array index, which starts with a default value of 0. You also discovered that arrays can only store values of the same type, like integers, floats, and strings. With your newly found knowledge on arrays, you should now be able to demonstrate how to create an array using the array literal syntax, demonstrate how to access and edit items in an array using the array index, and define the different array methods used to append, insert, and remove array items. Next, you moved on to learn that tuples also allow you to store a group of values. You discovered that tuples can hold many values and store a number of different data types. By completing the lesson items that demonstrate how tuples are used in practice, you should now be able to demonstrate how tuples are composed by enclosing a list of comma-separated elements in a pair of parentheses, explain what decomposing a tuple means in the context of extracting individual values, demonstrate how to decompose a tuple by assigning its elements to individual variables, and describe the process of accessing the values using the index numbers. In the following lesson, you moved on to learn how dictionaries allow you to look up values based on their identifier. More specifically, you learned that a dictionary is a collection of items where each item has a key and a value, and that these are called a key-value pair. By completing this lesson, you should now be able to describe what the function of a dictionary is, demonstrate how to create a dictionary by enclosing the key-value pairs in square brackets, demonstrate how to create a key-value pair by separating the related elements with the colon, and describe the different methods used to insert, retrieve, change, and remove items in a dictionary. The different data structures you learned about in this module form part of the foundation that paves the way to understanding the basic programming concepts that underpin the Swift programming language. This means that you are one step closer to understanding the programming fundamentals in Swift. Well done! Wishing you all the best as you continue your learning journey. Have you ever wondered how, when you turn the dial or press a different button on your washing machine for a specific wash, it just knows what to do? You select sports wash and the machine runs a wash cycle at the same temperature every time. Or you turn the dial to synthetics and the machine runs a wash for the exact same length of time each time. Functions work just like this, running the same set of stored instructions repeatedly without requiring you to adjust the settings every time. Functions provide you with the flexibility to create a set of instructions that are convenient to use in your code. In this video, you'll learn about simple functions in Swift. You will explore how functions are structured and how to declare a function in your code with the use of parameters. You will discover how to call or invoke a function with the use of parameters and then explore function return types. Finally, you will learn about using tuples to return multiple values in functions. You've already used a Swift function in this course, such as the print function, which is declared in the Swift library. Recall to use it, you execute its name followed by a pair of parentheses, and then you type a value such as a string like "Hello World." Let's start with what is a function and what does it do. One of the basic principles of programming can be summed with the acronym DRY. In other words, don't repeat yourself. And it's thanks to functions that you can avoid repetition. With functions, you can take several lines of code that perform a set of related actions, and then group them together under a single label. Then, when you need to run the code that you've saved, you just invoke or call the function. You can run the code as many times as you want. As functions are only defined once, they allow for the reuse of code. For example, suppose you need to create some code that adds 2 numbers and prints out the result. The process could be as follows. First, create 2 variables, a and b, and assign each a number value. Then create another variable, c, which holds the value of a and b added together. Finally, you output the value of c. This piece of code works and adds 2 numbers together, but what if you want to execute this code more than once? Well, you can do this by placing this block of code inside a function. To create or declare a function, you type the keyword func or func, then a space, and then the name of the function. You can name the function nearly anything you want. This name should be unique as each function usually performs a specific task. The name should help to identify and describe what the function does. In this example, it's named add2nums. After the function name, place a left and right parenthesis. The code to be executed will then be placed in between the left and right curly braces, and this is known as the body of the function. It's important to remember that a function declaration on its own doesn't execute the code. It's just specifying what operations should be performed once the function is executed. To run the function's code, you need to call or invoke the function, and this is achieved by typing the function name followed by the opening and closing parenthesis. Instead of saying run a function, developers may say that they call a function or invoke a function. But don't worry, all of these terms mean the same thing: to execute the code inside the function's body. Next, let's explore another major advantage of functions: the use of values. Did you notice how the add2nums example was just adding the numbers 10 and 20? These numbers are our chosen values for this function, but this is just one example of the use of values. With functions, you can send it any values you want, and you do this by defining something called input parameters when you declare a function. These parameters allow you to pass one or more values to the function when called. These values are known as arguments. Take, for example, the add2nums function created earlier. The function accepted no arguments, and no parameters were defined. Instead, variables were used to produce results. While you can use variables this way, there are limitations. For example, as variables a and b have specific values, the function always outputs the same result. So, let's change this function to make it more flexible, using input parameters and passing arguments. It's important to remember that functions aren't required to define input parameters. Not all functions require these. In order to pass values to the function, you need to create function parameters in the function definition. Parameters allow you to set changeable values on each function call. The values passed to the function are called arguments, and these are local variables that will hold the value of the passed data. Notice that if you have even more than one, then these are separated by a comma. When parameters, you must declare the type, for example, int. By setting a and b as parameters, you can pass in any 2 numbers as input to the function. Then the function will perform the calculation to add the numbers. Parameters allow you to set changeable values on each function call, and functions with parameters can accept any kind of value and result in clean, more efficient code. Building functions this way allows you to write flexible functions that can be reused with various values as many times as you need. For example, by passing values as arguments to the function add2nums, you can call it as many times as you want, and as long as you send it 2 values, it will add them together and output the result. Okay, so now you know how to create functions and pass values to them. Let's now explore how to return an argument from a function. A function can return a single value, and you specify what type of value the function will return. This is known as its return type. Then in the function body, you use the return keyword to return the final value, and this must be the last command that the function executes. It's also possible to return multiple values from a function. To do this, you need to use tuples. You may recall learning about tuples, which enable you to create and pass around groupings of values. By using tuples, you can return multiple values from a function as the values are grouped into a single compound value. Each value can be of any type and do not have to be of the same type to each other. For example, suppose you need to create a function that will accept two numbers and then output them in the order of the minimum and maximum. You need to calculate which number is the minimum and which is the maximum, and then return the result. In this lesson, you learned about functions in Swift. You're now familiar with the advantages of using functions, declaring a function with parameters, and calling a function with arguments. You also learned how to return values from functions. Working with functions is common in day-to-day development, and is one of the core skills a developer needs to master as they help you write more efficient, reusable code. In this video, you will explore further functions in Swift, such as function parameter names and embedded functions. So far, all the functions you've identified have parameter names for each parameter, which is the same value as the variable name. So, when you call the function, it can be unclear what each parameter is used for. Let's start with an example. I open up a new Xcode playground. I have a function example, hi there, that takes the first name and last name or surname as parameters. Inside the function, I use the variables fn and sn to store these values. But when I call these functions, it may not be clear to someone unfamiliar with functions in Swift, and it is hard to interpret that. However, I can remove the external names by adding an underscore before the variable names in the definition of the function. So, I add underscore before fn string, and I do the same before sn string. Notice that now at the bottom, when I call the function hi there, the variable names can be removed, and it now looks similar to other languages. So, after I remove the function names, I run the code, and I get the expected result. Hi there, Fred George. When it comes to functions, Swift is much richer than other languages. A particularly rich feature is that it can have external and internal parameter names. So here I have the function hi there, and where there is the underscore, I replace it with first name and surname for last name. I defined the variable as sn to be used internally and the type string, and then I've got surname and then sn and string also to be used internally. I will also implement the changes for the call of this function. So it will be first name Fred followed by last name or surname George. So here I am using fn and sn as I did earlier. However, now when I call this externally, I have first name Fred, surname George. I now rerun this code to be sure, and the output remains the same. This makes the interface much simpler, and it helps people use the functions because it explains what they need to provide. I can use different names inside the function that make more sense within that context. I can also have default parameter values. Let me bring up a different example now. In this case, I have a function named display, and I have underscore s1 underscore s2 as string and score. Now score is defined as an int. If I don't define it, it will give me an initial value of 0. So I can actually say, if I don't get value passed for that, insert a value. Now inside the function is concatenating or joining s1, s2 and score and assigning this to a name underscore variable. Then it prints out hello and the name score variable. Now if I call this function and put John and Roberts as arguments for first and surname when I call it, it will print John Roberts 0 because it takes that score value that I am providing. However, if I call it now with the arguments John, Roberts and score 100, it will now set that value to 100, so it will override that 0. Let's now explore function types. Function types are the signature of the actual function, from the parameters that are coming in and the parameters that are being returned. I have a function that adds two ints, like in a plus b, and it returns an int, which is indicated by an arrow towards the end of the function definition line of code. So this is basically a function type. In this case, this type of function takes two ints and returns an int. I may have another function that is a similar type, and I can use that to my advantage. Now let me create another function to illustrate that concept again. var math function : and then int within parenthesis, and then an arrow and int to say that it will return another int, then equal to my function add two ints. So I have a function add two ints, and I point an arrow to int, but I can actually store this function into a variable. That's why I have a variable math function, and as I said, its type is int, and it returns an int. So I can take the function name and store the function into math functions. But the point here is just to show you that the actual function of what it takes and what it returns is a function type. Now I can call the assigned function by adding a print function such as print result. And then I add \parenthesis math function, and inside math function I pass 5 and 7. I now run this code and the result is 12. So I can call the math function and it picks up all the characteristics of the add two ends that were stored in it. So that's another thing that you can do with Swift. And this is just a basic view of some extra features of functions in Swift. When something is anonymous, it means that the identity has not been revealed or has been withheld. In Swift, this anonymity exists too, using a technique called closures. And developers can access these anonymous snippets of code to use in their programs. In this video, you'll learn about closures and how they can be used to provide data encapsulation where the implementation of the code is kept hidden. You will learn how to define closures and pass them as a function argument. Finally, you will learn about sorting arrays using a closure. Closures are a self-contained block of functionality that can be passed around and used in your code. Recall learning about functions? Well, functions are actually special cases of closures. You can think of closure expressions as a piece of code that can be sorted in a variable. That variable can then be passed around the program and executed where needed. Recall that a function consists of a declaration using the keyword func, followed by the function name, then arguments list, and a return type. Then the code to be executed in a pair of curly brackets. Well, a closure is similar, except it begins with the open curly bracket, then the argument list, followed by the return type with the keyword in. Finally, the code block to be executed is inside a set of curly brackets. Notice that the closure does not have a name. It's because of this that they are said to be anonymous. Okay, so now you know what a closure is. Why would you want to use it in your code? Well, closures allow you to write flexible and dynamic code that is easy to read and interpret. What does this mean? Well, to answer this question, let's create a closure to explore how it can be used to output some text to the screen. First, create a variable named myClosure and assign it to the closure syntax. In this example, the closure will take no input and return no value. Then, in the body of the code, you can run a print function to output some text like myFirstClosure. To execute the closure, you call the variable name followed by the open and close parenthesis. Similar to functions, you can pass values to closures in the form of arguments. For example, suppose you need a closure to accept an argument in the form of a string. Once again, the closure will not return anything. It will just print the value of the string passed to it. You can also return values. For example, suppose you want to return the maximum value between two numbers. First, you create a closure that takes two parameters, num1 and num2, which are both integers. Then you also specify the return type as an int. Next, you can use the return statement to execute something known as a ternary operator. This is very similar to how the conditional if statement works. You first have a condition. For example, num1 is greater than num2. Then you have the question mark symbol and the two parameter names separated by the colon symbol. If the statement is true, the parameter to the left will be returned. If false, the parameter on the right will be returned. You can basically think of the ternary operator as writing an if-else statement on one line. In this example, the print function is calling the closures and passing two arguments in the form of the values 1 and 6. When these values are passed into the function, the ternary operator checks if 6 is greater than 1, and because it is, the value of num1 is returned. Likewise, you may recall passing values to a function in the form of arguments. Well, because you can store closures and variables, you can then pass this variable and its associated functionality as a function parameter. And a good example of this is the built-in sorted function. This can accept a function or a closure to determine how the sort should work. In the next video, you will explore this in a little more detail by analysing an example on sorting arrays. The built-in sorted function is a good example to demonstrate the use of closures. It takes two arguments, an array of values of a known type, and a closure or a function. It is a method that works on the array and returns true and false. And then the sorted function generates a new array with everything in the right sequence for that sort. So, let's start with an example where I'm using function first. First, I will be using the sorted method with a regular function, and then I will demonstrate how I can use the same approach with closures. First, I create a function called forwards, and with two strings, s1 and s2 as parameters. The function returns a boolean as a result. Inside the function body, it returns the boolean result of the comparison where the condition checks if s1 is greater than s2. So far, the code in the forwards function means that if the value of string s1 is greater than the value of string s2, the value of true is returned. Next, I create an array called letters containing 4 array items, H, E, X, and A, all in uppercase. To sort this array, I can pass the array to the sorted function and store the result in a variable. First, I create a variable called sorted, and then assign to it the letters array with the sorted method applied. I do this by typing letters dot and select the sorted by method from the drop-down option in Xcode. Then, inside the parenthesis, I add the name of my function forwards after the colon symbol. When I run this code, it will first compare if the first item in the array H is greater than the second item in the array E. It will compare the letters with each other and swap them around. It will sort this using its logic, and I will just have to trust it. Let me demonstrate this now by outputting the sorted array using the print function. On a new line, I type print sorted to output the result of the code to my screen. The output, XHEA, is displayed at the bottom of my screen. Notice that the letters are sorted in descending order. Now that I know what can be done, let me do the same with closure, all in a single line of code. To do this, I create another variable called myCollections and assign it the following. First, I once again place the letters array with the sorted by method. Next, after the colon, I insert the code I need to use a closure. First, I type open and close curly brackets. Inside those, I place open and close parenthesis, and inside that, I insert s1 colon string, comma, s2 colon string. Now, outside the parenthesis, I place the code to return a Boolean result. After the keyword bool, I type the word in. Then on the next line, I type return. And finally, s1 less than s2. To determine if my code is working, I run the print function to output the value store in the variable myCollections. Notice that the results are the opposite of my previous result, AEHX. The reason for this is that the comparison operators are different, but the logic is the same as what I demonstrated when using functions. Because the closures pass arguments to the function, Swift can infer the types so it can work out some of these things and simplify them. In this example, I have the original closure, but because Swift can infer types, I don't need to know what S1 and S2 are because I have an array of letters and I know what's in that array. I can further optimize this code by removing all the types. I do this by deleting the colons and strings after S1 and S2, as well as the arrow and Boolean. When I run the code now, it works the same way, and the result displayed at the bottom of my screen is the same as the previous result. I can simplify my code even more. In Swift, it is possible to omit the parameter names in closures. When doing this, you refer to the omitted argument with a $ symbol followed by the index number of the array. For example, I start with $0, then $1, and keep on adding until all the arguments have been replaced. To demonstrate this, I copy the code on line 12 and replace everything inside the curly braces with $0, $1. Let me just cut and paste this print function under my new code. In order not to get a variable declaration error, I comment out the previous code for my collection on line 12. Notice that a less than sign has been added between $0 and $1. 0 and 1 can be viewed as indexes of an array. $0 and $1 is called shorthand argument names. If I run the code again, the result should be the same. And that's a brief introduction to closures, how to create them, and a simple example of how to use them. In this video, you learned about closures and how developers can use them to write anonymous code that can be stored in a variable to be executed anywhere in the program. You also learned how closures are useful by providing functionality to sort an array of values. Well done! You've reached the end of this module on functions and closures. It's now time to take a moment to reflect on the key concepts you learned about. You began this module with a lesson on functions and learned how they are used to keep commonly used algorithms in one place so that they can be reused. You explored different examples to experience firsthand how they make your code cleaner and more efficient. You then moved on to learn about closures. You explored different examples that demonstrate how closures store functionality in constants and variables. Next, let's delve into what your newfound knowledge enables you to achieve. Having completed the lesson on functions, you should now be able to describe how functions are used to run the same set of stored code repeatedly without having to adjust the code every time. Demonstrate how functions are declared and structured with the use of parameters. Illustrate how to call or invoke a function with the use of parameters. And identify different function return types. With this new understanding of functions, you should also be able to explain how tuples are used in functions, and list the main types of functions. Next, your completion on the closures lesson equipped you with a foundational understanding on how closures are used for data encapsulation, where the implementation of the code is kept hidden, which you might recall is known as writing anonymous code. You should now be able to describe how closures are used as self-contained blocks of functionality that can be passed around and used in your code. Demonstrate how closures are declared and executed, explain how to pass values to closures in the form of arguments, and explain how to use closures to return values. You should also be able to demonstrate how to use closures and function parameters to sort an array. As you completed this module, you also had the opportunity to practice what you've learned by completing the individual exercises for functions and closures. By practicing using functions and closures, you should now be able to understand how they can be applied to real-world scenarios. The self-review quizzes allowed you to reflect on the exercises, which helped you to reinforce what you have learned. Throughout your learning journey, you were introduced to several essential skills and concepts of programming in Swift. And as you continue to develop your skills and understanding, it's important to give yourself ample time to practice the different concepts you have been introduced to. You've come quite far and reached several milestones along the way. You have made great progress. Well done.
When coding a program, you may find yourself searching for ways to encapsulate programming logic. This means packaging related code, such as constants, variables, and functions into an existing or new data type. In Swift, this can be achieved using a structure. Over the next few minutes, you'll learn what structures are, how to define them, and how to use them to store values and functionality. Suppose you are creating a repository for all the different dishes on Little Lemon's menu. Instead of having a piece of code here and a piece of code there, you can use a structure to package the related code. A structure, commonly referred to as a struct, is a value type instance that works as a general purpose program block for your code. A value type is an instance that contains a unique copy of its data. When you assign a value type like a structure to a variable or constant, the compiler copies the data as a new copy. There will be no linkage between the new instance and the original. This is useful when you don't want changes made to a single instance to affect another. To understand how you can encapsulate your code with a struct, let's first review what a struct comprises of. Generally, structs contain properties, methods, and initializer methods. Properties are the constants and variables declared inside a struct, while methods refer to its functions. Initializer methods create a struct instance and can be used to set the initial property values. Some structs may contain only properties or only methods, or a combination of both. Let's explore the syntax before moving on to an example. To define a struct, you insert the struct keyword followed by an identifier and a pair of curly braces. Then, you specify the properties and methods that belong to the struct inside the curly braces. The code defined in the curly braces is called the struct definition. Next, let's explore an example of how to define a struct for Little Lemon's menu item repository. First, insert the keyword struct followed by the name menu item. Then, insert the struct definition, add two properties, a name constant of type string, and a price variable of type double. If you wish to add functionality to a struct, you can define a method inside the struct definition. For example, you can create a method called getInformation with a string return type. Then inside the method body, return a string interpolation of the name property and the price property. Great, the method has been defined. What now? To use the struct, you use an initializer method to create a struct instance. Every struct comes with an auto-generated initializer called a member-wise initializer. The member-wise initializer helps set the initial values in a struct instance. Let's explore an example. First, let's define a constant in the new struct instance. To use the member-wise initializer, type the name of the struct followed by an open parenthesis. Xcode will suggest an autocomplete of the member-wise initializer. You can use the autocomplete or type out the parameters. At this point, you can pass the super spaghetti for the name parameter and 17.99 for the price parameter. Now, the super spaghetti constant contains a new struct instance with its own custom property values assigned to it. You can also create a custom initializer method. Suppose you want to order the parameters in the order of importance for intuitiveness. You can use a custom initializer method. Another common custom initializer method use case is to provide default parameter values. With parameter values, you can create a structure instance without needing to explicitly provide an initial value for every property. To create a custom initializer method, you insert the keyword init instead of func. Then you insert the method parameters in the order that you want. So, to prioritize the price parameter before the name parameter, you insert a price parameter of type double. Then, you insert a name parameter of type string. Next, to refer to the property inside a struct instance, you type self followed by the dot syntax and the property name. Then, you use the assignment operator to assign a property instance to the initializer parameter value. This helps differentiate between the parameter in the initializer method and the instance property. The process of providing a default parameter value in a custom initializer is the same as providing one in a function. For instance, for the price parameter, you can assign the value of 9.99 using the assignment operator, and unknown for the name parameter. Next, let's explore an example of the different ways to create a struct instance with the custom initializer. Suppose you have an unreleased menu item, affogato, priced menu item, and super spaghetti struct instances. For the unreleased menu item, you do not pass in any parameter value and you use both initializer default parameter values. Then, you have affogato that passes only affogato in the name parameter. Similarly, with price menu item, you only pass in one parameter value and you set the price to 12.99. And for super spaghetti, you utilize both parameter values passing 17.99 for the price parameter and super spaghetti for the name parameter. If you print the getInformation method on the struct instances, the console logs unknown 9.99 for the unreleased menu item instance, Affogato 9.99 for the Affogato instance, unknown 12.99 for the priced menu item instance, and Super Spaghetti 17.99 for the Super Spaghetti instance. You've now learned that structures are used to create building blocks for your program's code. You've familiarized yourself with the Swift syntax, and you should now know how structures are defined with properties and methods to store values and functionality. You should also be able to create new instances of a structure using either the default member-wise initializer or your own. Well done. You have learned that using a structure helps you organize your data and functionalities. Instead of having fragmented data and functionalities throughout your code, a structure helps you package them into a single instance. At Little Lemon Restaurant, the menu app has an extensive list of offerings including food, drinks, and desserts. The common thread between these offerings is that they all have recipe ingredients. The recipe ingredients allow the staff to understand the ingredients necessary to prepare the menu items, and the customers can view the ingredients to check for any allergens. In addition to the ingredients, each recipe has a name and steps to make the dish. In this video, I'll create a recipe structure to encapsulate recipe-related data and functionalities. Let's begin. First, I define a recipe structure instance by typing the struct keyword followed by recipe and curly braces. Recipe is the identifier of the structure. Next, I need to add properties and methods to encapsulate the relevant data and functionalities inside the structure. The properties and methods are added to the structure definition between the curly braces. The first property I'll add to the recipe structure is for the name of the recipe. Inside the structure definition, I declare a constant called nameOfTypeString. The second property I'll add to the recipe structure is the ingredients for the recipe. Inside the structure definition, I declare a variable called ingredients of type set of strings. I choose to use a set here because the ordering of the ingredients does not matter. I also deliberately set the ingredients property as a variable to allow the property to be altered after initialization. The third property I'll add to the recipe structure is the steps for making the recipe. Inside the structure definition, I declare a variable called steps-of-type-string-array. I choose to use an array here because the ordering of the steps does matter. I also deliberately set the steps property as a variable to allow the property to be altered after initialization. Now, to conveniently display the properties inside a recipe, I'll create a method to print the recipe name, ingredients, and step-by-step instructions. Inside the recipe structure definition, I add a method called printDescription. In the body of the method, I print recipe, string interpolation of name. In the next line, I print ingredients, string interpolation of ingredients. Then I enter a new line and use the enumerated method on the steps property to loop through the steps while getting access to the current index and step value. At each iteration, I print string interpolation of current index +1, followed by a period and a space. Then to complete the print statement, I add a string interpolation of step, followed by a period. I'm adding a 1 to the index because the index starts at 0, and I want the step counts to intuitively start reading at 1. At this point, I have defined a recipe structure with 3 properties and a method. This is an example of encapsulating data and functionalities inside a structure. Now, I'll demonstrate how to initialize a structure instance. To initialize a recipe structure instance, I'll simply need to type recipe followed by an open parenthesis, pass in the parameter values into the initializer method, then add a close parenthesis. For the name parameter, I enter chocolate cookie. For the ingredients, I enter cocoa powder, chocolate chip, and flour. For the steps, I entered first action, second action, third action. Now I assign the struct instance to a chocolate cookie recipe constant. At this point, I have initialized a structure instance and assigned it to a constant. Now I can use the print description method to conveniently read the data of the chocolate cookie recipe. In a new line, I type chocolate cookie recipe followed by the dot syntax and the print description method. When I run the code, the console logs the recipe name, ingredients, and steps. By completing this video, you should now be more comfortable with defining and initializing your own structures to better communicate the intent of your code, to organize your code, and to make your programs more expressive. So far, you've learned that structures allow you to encapsulate your programming logic by grouping related data and functionality in a meaningful way. And, as you may recall, this takes form as properties and methods. As a developer, you may encounter a situation where you need to alter the properties within a structure. And when this happens, you need to use a mutating method. Over the next few minutes, you'll learn what a mutating method is and why it's useful. You'll also explore the process of creating a mutating method in a structure with a practical demonstration. By default, methods within a structure cannot alter the values of its properties. A mutating method, on the other hand, explicitly states that the method will alter a property and that the property you alter is assigned a new instance when the new value is assigned. As a result, developers using structures need to be conscious about altering property values in a structure. The Swift programming language uses mutating methods to achieve this. Let's position this with a scenario. Little Lemon wants to track the order count for specific recipes. They also want to increment and decrement the order count. Let's explore how this can be done with a structure and mutating methods. First, I create a structure called recipe. Then inside the structure definition, I add an order count variable property with a default value of 0. Now, I want to create two methods to conveniently update the order count property value. One to increment and one to decrement it. If I were to use a non-mutating method to change the property value in a structure, the compiler will throw an error. For example, in the struct definition, I add two non-mutating methods, one to increment and another to decrement the order count. The increment order count non-mutating method uses the addition operator followed by 1 on the order count variable. The decrement order count non-mutating method uses the subtraction operator followed by 1 on the order count variable. As noted earlier, the compiler throws an error stating that self is immutable, informing me that the property value cannot change. However, the compiler also suggests marking the method with the mutating keyword to make the struct instance self-mutable. Self indicates the structure instance or the recipe structure in this case. So to convert both non-mutating methods to mutating methods, I simply insert the mutating keyword before the func keyword for both. Great! Now that I have created the mutating methods, let's explore how they are used. At the bottom of the playground page, I create a recipe variable and assign it with an initialized recipe instance. I use a variable here to make the recipe struct instance a mutable value. This is necessary to increment or decrement the order count inside the recipe struct instance. Next, I print the recipe order count. And now I run the code. The console logs 0. This is the default value of the initialized property. Next, I call the increment order count method on the recipe variable. Then I print the order count of the recipe. Now when I run the code, the console logs 1. This confirms that increment order count mutating method is working on the recipe struct instance. Now let's check that decrement order count works as intended as well. I call the decrement order mutating method on the recipe variable and print the order count of the recipe. I run the code and the console logs 0. Great. The decrement order count mutating method behaves as expected. And that's all you need to write and use mutating methods within a structure. I've created a feature that helps track and update Little Lemon's order count using a structure and mutating methods. In this video, you've learned that mutating methods make it possible to alter property values within a structure. By following the practical demonstration of incrementing and decrementing values, you should now better understand that declaring a method as mutating explicitly states that a property value within a structure can change. And when a property value change occurs, a new structure instance is assigned. Earlier, you learned that structures allow you to group related code in a single package. You may also recall that since structs are value types, every new instance creates a copy of its data, and this means that there's no linkage between the original and the new instance. Now, what if you want a way to encapsulate your code but still maintain that link? In Swift, classes allow you to do just that. Over the next few minutes, you'll discover what classes are, explore a few examples where classes might be used to solve a common problem, and examine the Swift syntax for creating a class. To begin, imagine the following scenario. Mario wants to improve Little Lemon's signature chocolate chip cookie recipe and asks his colleague Adrian to help. The recipe is updated on the system so that all other chefs have live access to the most recent version. Both Mario and Adrian read and modify the same recipe on the system. This is an example of using a class to share a copy of the data. A class is a reference type, and unlike value types, when a reference type is assigned to a variable or a constant, a copy of the data is shared. Don't worry too much about what this means now. You'll learn more about the differences between value and reference types later. Let's move on to define a class instance for Mario's chocolate chip cookie recipe. To define a class, I insert the class keyword followed by its name recipe and a pair of curly braces. Inside the curly braces, I can add properties and methods. For now, I'll declare a variable property named ingredient of the type string array. When declaring properties without an initial value in a class, the compiler will notify you that your class has no initializer. A member-wise initializer is a method to set the initial property values of a new instance, and it's important to note that a class doesn't come with an auto-generated member-wise initializer like a structure. To fix this error, I can create a custom initializer method in the class. An initializer method, also referred to as an initializer, allows you to specify the initial property values when creating an instance. To add an initializer to the recipe class, I use the init keyword followed by the open and close parentheses. Like functions, I can specify the parameters of the initializer. Typically, and by convention, I can name the parameters the same as the properties. Inside the initializer body, I refer to the class instance by typing self, followed by the dot syntax and the property name. Now I can use the assignment operator to assign the parameter value to the property. For properties with a default value, I won't need to initialize that particular property value inside an initializer. For example, I can add an isAvailable property and set it equal to false. The default value is the initial value for a property unless the initializer set it to another value. With this recipe class instance, the recipe ingredients data and isAvailable state is shared across variables. If two variables share a reference to the same recipe class, and the recipe's ingredients property is set to a different set of ingredients, then both variables refer to the same data. If the recipe's isAvailable property is set to true, then both variables also refer to the same state. Now I can create recipe instances using the initializer. For example, I instantiate a recipe instance with cocoa powder and flour for the ingredients parameter and assign it the Mario recipe constant. Classes are an important part of programming in Swift. You've now learned that, like structures, classes are general-purpose building blocks for your program's code. You've also learned that classes are reference types, and this means that a copy of the data is shared across instances. You explored a few practical examples and should now be able to define your own classes using the appropriate Swift syntax. So far, you've learned that both structures and classes are general-purpose building blocks for your code. Now you might be wondering, what type of building blocks should you use for your programs, and what makes them so different? Well, as you might recall, structures are value types, while classes are reference types. And over the next few minutes, you'll learn more about the similarities and differences between them so that you can better understand which to use for your code. In the Swift programming language, there are two categories of data types: reference types and value types. The key difference is how they behave in the memory of a computer when running code. Do you recall Little Lemon's signature chocolate cookie recipe from earlier? Suppose that instead of Mario and Adrian modifying the same recipe on a system, Mario sends a copy of the recipe directly to Adrian to edit. Both Adrian and Mario have their own copies. So, when Adrian makes changes to his copy, it won't affect Mario's. This is the function of a value type. A value type always stores a copy when assigned to a variable or constant. Let's review an example of how this scenario can be presented in code using structs. First, you define a recipe structure with an ingredients property of type string array. Then, you create a recipe instance with cocoa powder and flour for the ingredients parameter and assign it to a Mario recipe variable. Next, you assign the Mario recipe variable to a new variable called Adrian recipe. This copies and assigns Mario recipe's value to Adrian recipe. Adrian recipe is now another instance of the recipe structure with its own copy of the ingredients. Changing a property in Adrian recipe won't affect Mario recipe. For example, suppose you update the ingredients property of Adrian recipe to only cocoa powder. The ingredient property of Mario recipe will remain as cocoa powder and flour. If you print the ingredients of Mario recipe and Adrian recipe, you'll observe that the console logs cocoa powder and flour for Mario recipe and only cocoa powder for Adrian recipe. The example demonstrates how a value type instance creates a copy of its data. Reference types, on the other hand, behave differently in a computer's memory. Instead of storing a copy when assigned to a variable, it stores its location memory like a memory reference. Next, let's review what happens when you use a reference type. Using the same recipe instance code example, let's replace the struct keyword with a class keyword. Now, updating Adrian recipe's ingredients also updates Mario recipes. This is because the variables point to the same memory reference. And if you print the ingredients of Mario recipe and Adrian recipe again, you'll notice that the console logs cocoa powder for both. When it comes to using reference types, like classes, making a value change in one area of your code could affect 10 other parts of your program. For this reason, it's recommended that you use structures as your main building blocks, since they are less likely to cause unexpected programming behavior. Reserve the use of classes for when you need a shared state that changes over time. With that being said, you'll use a mixture of value and reference types throughout your career as a Swift developer. So if you ever get stuck deciding which one to use, just think of the examples you explored in this video and you should be well on your way. So far, you've explored how properties are used in classes and structures to store values where class or structure instances are used. But did you know there is more than one property type? Swift offers two types of properties, stored and computed properties. And over the next few minutes, you'll learn about the key difference between them. Throughout your learning journey, you came across different scenarios where stored properties were used for storing values to class and structure instances. More specifically, you encountered two stored property variations, namely constant stored properties and variable stored properties. Recall that to create a constant stored property in a class, you use the keyword let, and for a variable stored property, you use var. Each stored property can be provided with a default value, or you can use an initializer to set the initial value of stored properties. So, what about a computed property? What would you use it for? Unlike a stored property, a computed property calculates a value and then returns the result of the property declared type, almost like a function with a return value type. And whereas a stored property can be read and written to, a computed property is read-only. Whenever you need to encapsulate a block of computational code or calculate a value more than once, you can use a computed property. Let's move on to a demonstration of creating a computed property in a class. I have created a menu class with mains, drinks, and desserts stored properties. Each of the stored properties is of type string array. It would be convenient to have a menu items count computed property that allows me to calculate the number of menu items available across the main, drink, and dessert categories on the menu at once. To begin creating the menu items count computed property, I type var menu items count. Then I declare the computed property as type integer. The computed property body will return an integer for the menu items count. This is because the declared computed property type is an integer. Inside the computed property body, which is between the curly braces, I create three constants: mains count, drinks count, and dessert count to store the menu items counts from each category. I broke down the code into multiple lines to make the calculation easier to reason about. In addition to using multiple lines, I can also use a single expression if I want to write more succinct code. For a single expression, I can omit the return keyword for a shorter line of code. Instead of separating the menu items count into three separate constants for the three categories, I will first remove the current computed property body content. Then, I simply type mains.count plus drinks.count plus desserts.count. This is an example usage of a single expression inside a computed property body. I've demonstrated the creation of a computed property in a class. It's also worth noting that the process and logic behind creating a computed property in a class also apply to a structure. You've now learned how a computed property calculates and returns a value of the computed property type and how to create computed properties inside a class. And while stored properties are more commonly used, you learned that computed properties are especially useful to perform calculations. As a result, you now have another tool under your belt that can be used for the right job. You've come a long way to build your understanding of the programming fundamentals in Swift. Soon, you'll be able to integrate your new knowledge to engineer solutions for the end of course project. But first, let's recap what you've learned this week. Following your completion of the different video items, readings, exercises, and quizzes, you now know that structures and classes allow you to pass around properties and methods acting as fundamental building blocks for your code. More specifically, you learned that a structure commonly referred to as a struct is a value type instance. This means a new struct instance makes a unique copy of its data. You explored the Swift syntax to create a struct and discovered how to define struct properties and methods to store values and model behavior. You also discovered that every struct comes with an auto-generated initializer called a memberwise initializer, and that the memberwise initializer helps set the initial values in a struct instance. You also learned about creating your own initializer method to assign property values by defining a method in the struct definition using the init keyword. Thereafter, you discovered that mutating methods allow you to alter struct properties. Then, following a hands-on exercise using mutating methods, you moved on to learn about classes and reference types. Like structs, classes act as general-purpose programming blocks for your code. And when a reference type like a class instance is assigned to a constant or variable, it stores its memory location. You discovered that a change to a class instance affects the class instance that references it, and that changes are shared across instances when working with reference types. What's more, you evaluated how classes are different from structs by distinguishing between value and reference types and exploring use cases for both. You then moved on to learn more about stored and computed properties. You discovered that a stored property stores a value in a constant or variable, while a computed property calculates a value and then returns the value to the declared property value type. You should now be able to differentiate between structures and classes as value and reference types, and identify when to use one over the other.
In this course, you explored the fundamental skills of programming in Swift. Let's take a few moments to briefly recap what you learned. In the opening module, you had an introduction to the course and explored possible career roles that you might want to follow as an iOS developer. You also reviewed some tips on how to be successful in this course and discussed what it is that you hope to learn. You had a tour of the Swift playground, and you learned how to create and store data using constants, variables, and data types. You also learned how Swift automatically detects the type of data you want to work with using type inference. You learned how to use operators to perform operations on variables and values to manipulate individual data items and return a result. You started by learning how simple arithmetic can be performed with mathematical operators. You started by exploring the concepts of conditionals, loops, and optionals, and how developers use them to program decision-making in their code. You learned about the different types of loops used in Swift and how they can be used to perform repetitive tasks. You then learned optionals and the concepts of nil, forced unwrapping, optional binding, and implicitly unwrapped optionals. You then moved on to explore data structures and arrays. You learned how Swift sequences array items using an index value, while discovering how to use different array methods. Next, you learned about tuples and how they are used to store any and many different data types. After that, you discovered that developers use dictionaries when they need to look up values based on their identifier or key. To conclude your learning on different data structures, you explored how to use loops with collection types. You were taken through the process of using for-in loops with arrays and dictionaries, building on the knowledge you've just gained. Finally, you were introduced to functions and closures. You learned that functions can be used to run the same set of stored instructions repeatedly. You also discovered how to structure and declare functions, and then learned how to use tuples to return values in them. You then moved on to learn about closures in Swift and how they can be used to provide data encapsulation where the implementation of the code is kept hidden. Well done! Now it's time to try out what you've learned in the graded assessment. Good luck! Congratulations on reaching the end of this course. You've worked hard to get here and developed a lot of new skills during the course. You're off to a great start with your Swift development learning journey, and you now have a fundamental understanding of programming in Swift. You were able to demonstrate some of this learning, along with your practical Swift skill set, by creating a bank account in the Project Lab. Following your completion of this course, you should now be able to demonstrate knowledge of and explain the difference between constants, variables, and data types, list crucial data structures and describe how they store data, explain that the role of functions is to keep commonly used algorithms in one place, and that closures are used to store functionality in a constant or variable. Since this course provided you with an initial introduction to several key areas, you might be wondering, what's next? This course on Programming Fundamentals in Swift forms one part of the iOS Developer Professional Certificate, so you may realize that there's still more for you to learn. So, if you found this course helpful and want to discover more, we recommend registering for another. You'll continue to develop your skill set during each of the iOS developer courses. In the final capstone project, you'll apply everything you've learned in all the courses. Whether you're just starting out as a technical professional, a student, or a business user, the course and projects prove your knowledge of the value and capabilities of iOS development. The lab consolidates your abilities with the practical application of your skills. But the lab also has another important benefit. It means that you'll have an app that you can reference within your portfolio. This serves to demonstrate your skills to potential employers. And not only does it show employers that you are self-driven and innovative, but it also speaks volumes about you as an individual, as well as your newly obtained knowledge. And once you've completed all the courses in this program, you'll receive certification in iOS development. The certification can also be used as a progression to other role-based certifications. Depending on your goals, you may choose to go deep with advanced role-based certifications or take other fundamental courses once you earn this certification. This certification provides globally recognized and industry-endorsed evidence of your technical skills. Thank you. It's been a pleasure to embark on this journey of discovery with you. Best of luck in the future.